Hi everyone. So in this video we will study about MOS amplifiers, which is a very important topic for your upcoming GATE EC examination. So who should watch this video? This is the first point. So if you are someone who did not study this particular topic and you are thinking that you will completely drop it, then you should watch this video, because here I am gonna tell you problem solving skill, that how you would be able to solve the problem in the examination. Here I'm not gonna dive deeper into the concept. Here only thing I'm gonna tell is how to solve the problem in the examination. So if you are someone who completely skipped this particular topic, then you should watch this video, because what I feel is that this should come for 3 to 4 marks. So you can watch this video, or if you are someone who has already studied it but you are not feeling so much confident in this particular topic, then you can watch this video. Okay. So yeah. So in this particular video we are not going to solve any challenging problem or any exceptional problem. Here we are going to see the basic problem which can be asked or which have been asked in the examination. Okay, so if you are someone who is already confident with this particular topic, then you can skip this video. So with that we will start learning our MOSFET amplifier. So before going into MOSFET amplifier, first let's understand the basic meaning between large signal and small signal. So again and again when you see a problem of a MOS amplifier, there will be these two terms, large signal and small signal. So what is the meaning of that? So let's just consider this mic I am having. So in this mic, how many input signals are there? How many input signals are there? So first thing is that this mic is connected through a wire from PC. So when I turn on the PC, what it does, it turns on the mic as well. Like this mic is getting one supply from the PC. So this is the one input it is getting. The other input is my voice. The job of this mic is to amplify my voice. So one thing is that the supply from the PC, the supply from the laptop is turning on this mic. So first you need to turn on this mic. Let's just say I did not even turn this mic and I am saying something. Will it amplify my voice? No. First I need to turn it on. So for turning it on, I need to give it a supply. So that supply is our large signal. And that signal is DC. So from the laptop, it is getting some constant 0.8 volt. It could be 5 volt. It could be 2 volt. Something it is getting from the laptop. The other input is my voice. Like I am saying something, it is amplifying it. So that is the other input. And that signal is small signal. Why do we call it small signal? So generally this large signal is DC bias, 0.8 volt, 5 volt, 2 volt. And this is small signal. So this input, this voice input, that will have amplitude of some millivolts. 20 millivolt, 10 millivolt, 5 millivolt. So that is a AC signal. The signal would be something like this. So the voice that is coming from me, that would be a AC signal. The amplitude will be varying. So I am saying that my voice is some 20 millivolt sine omega t. This is my voice. Now why I am saying that this signal has to be small and this is large? So let's just say to turn this mic on, I need 0.8 voltage. To turn this mic on, I need 0.8 voltage. So from the PC, I am giving it 0.9 voltage. Like if my voltage is 0.8 or greater than 0.8, then my mic will turn on. Okay. If my voltage is 0.8 or greater than 0.8, then my mic will turn on. So what I did, I gave it 0.9 voltage so that my mic is turned on. So now my mic is turned on. Now what do? I will apply my voice signal as well, no? Because I need to give it a voice. Because the job of this particular mic is to amplify my voice. So I will give a signal as well. That should be my voice. Now let's just say I gave the signal of amplitude 0.2 sine omega t. Now what is this? This is my applied input. This is my voice. This is my voice. And this was the DC bias. Now how my voice will look like? This is how my voice will look like. It can go plus 0.2, it can go to minus 0.2 as well. Now what will happen? This DC bias and this voice signal will be superimposed. Basically the total input that is applied to the mic will be 0.9 plus 0.2 sine omega t. Now maximum it can go up to 0.11 and minimum it can go up to 0.7. So if it is going towards 0.11, then it's fine. Mic is turned on. But if it is going towards 0.7, then mic will be off. So here I was expecting, at this point I was expecting that my voice will be amplified. But what will happen? If mic is not even on, then how the voice will be amplified? So the reason is, if I am superimposing a small signal, a different input, a small signal, if I am superimposing on the large signal, then the signal has to be small. So this AC input has to be small. So that's why it is known as small signal, and it will have a very small amplitude. So in the examination, you don't need to worry about all these things. I told this particular topic just because you should know what we are going to study. We are going to study that how this particular device will amplify my voice, how much amplification it will give. So that thing we are going to study. But in the question there will be word written large signal, or it can be written DC bias. There will be small signal, there will be AC input. So you should have an idea what do we mean by small signal, what is the meaning of AC input, why we are giving it a DC supply. So DC supply we are giving to turn it on, and this AC input is the input that user is applying. That means that I am applying that so that my voice gets amplified. So the job of analog designer is to design a particular amplifier. He will design a particular amplifier. He will tell the user that to turn it on, you give this particular amplifier so this much amount of voltage. Let's just say 2 volt. When it is turned on, now you can apply another small signal input here. So there are 2 input on this amplifier. One is the supply, which is shown by VDD, and this is small V in, which is given from the user. I hope you would have understood this point. Let's go to our analysis part now. Okay, so I will remove all this off, because here I just wanted to let you know that what we are going to study. Okay, same goes for this loudspeaker as well. I thought I would explain it with loudspeaker example as well. Same goes for this loudspeaker. First we need to turn it on, then we will give it a song. Like we can insert some song in this one, then it will be amplifying the song as well. Like we use this loudspeaker at some occasion, no? So first we need to turn it on. So that is the DC bias. And then we will apply some song to it, and that will be amplified. So that is the small signal. So we will study this analysis only. We study this analysis as well, but this is also important, but not that important. And this analysis is pretty straightforward. But now we are going to study this small signal analysis, this AC analysis we are going to study. Now, important thing, whenever you are studying small signal analysis, at that time you will ignore large signal. That means you will nullify all your large signals. Basically, if I am doing the analysis of small V in, then whatever the supply that I have applied, VDD, that will be shorted. This is my amplifier. Okay. It is having a VDD supply as well. It is having V input as well. And it will generate some V out. So if I am studying this analysis, if I am studying about this guy, then I will nullify this VDD. Okay. Not only VDD, it can have some current source as well. In place of this VDD, there can be some current source as well. VDD, IDD, IDC. So when I am studying about this V in, this IDC will be nullified. That means this will be open circuited. Nullifying means you understand, right? Voltage source will be shorted and current source will be open circuited. So here current source will be open circuited. And why do we do so? That region I explain, but in the comprehensive course, not here. Okay. It will not be possible to explain that particular topic or that particular point here in this course, because here we are just looking at the problem solving. So first 10 minutes I wanted to spend just to let you know that what you are studying. So I hope the idea is clear now that what you are studying. Now let's get started with our MOS amplifier. So you will see this kind of structure in the examination. What you will see, this kind of structure. So if the arrow is outward, okay, if the arrow is outward, this is known as NMOS. What it is known as? NMOS. If the arrow is outward, this is known as NMOS. Okay. This arrow is there, no? So this particular node is known as source. Even if you forget these names, then also it is fine. This particular node is known as source. You are not going to forget it, because we will solve a lot of problems. So you are eventually going to remember it. After 1 or 2 hours of this video, then eventually you are going to remember these points as well. So this point is known as source. Wherever you see the arrow, that is source. The middle one is gate, and one which is left, that is drain. All fine? Okay. Now there is a small signal resistance R0 is present between drain and source. It will not be shown. In the examination, only this much structure will be shown. In the examination, only this much structure will be shown. But you should understand on your own that there will be one R0 present as well. One resistance is also there between drain and source. Are you getting this point? Between drain and source, there will be one resistance present. Is that clear to you? Okay. Now let's see about our small signal analysis. So this is my, let's just say here I have applied some small signal V1 voltage, and here I have applied some small signal V2 voltage. Okay, and here there is a resistance, that is R naught. Now in this MOS, in this particular MOS, in this device, how much small signal current will flow? The current will be Gm into V1 minus V2. How I am writing down the current? The current is, in which direction I am writing down the current? I am going from V1 to V2. I am writing down the current in downward direction. So what current I will write? Gm into, I am writing in the downward direction. That means I am going from V1 to V2. So Gm into V1 minus V2. That current I am writing down. And R naught is also present. Okay. Now let's just say I need to write down the current in upward direction. Let's just say I need to write down the current in upward direction. I can write down the current in upward direction as well. This current is flowing from this device. That's it. There could be any circuitry here. There could be any circuitry here as well. But if I know the potential of gate, if I know the potential of source, if I know these two potential, the potential where there is arrow and the potential which is there right in between. This right in between is known as gate. This is known as source. So potential at the arrow if I know, and potential that I know right in between. So if I know these two potential, and if I need to write down the current, then certainly I can write down the current as well. I can write down the current in downward direction as well, in the upward direction as well. So how will I write down the current in the upward direction? So what will be the current? Gm. What is this Gm? I will tell you. Okay, Gm into, where I am writing down the current, upward direction. So where I am going from V2 to V1. So Gm into V2 minus V1. So this is how I am writing on the current. This current is flowing from this MOS, not from this R naught. This current is flowing from this MOS. Okay, is that clear to you? So in both of the direction you can write down the current. Just you need to know these two potentials. Just wait a second. Yeah, so you would have understood this point. So I am again making this circuit. Again I am making this circuit. Okay, we know all the potential. This is known as gate, source and drain. Between drain and source, from here to here, there is a resistance R naught. Now let me know if this potential is V3 and if this potential is V1. Can I write down the current in MOS? No. For writing down the current in MOS, you need to know this potential, that is V1, and you need to know the potential where there is this arrow, which is this V2. Now I can write down the current in downward direction as well, in upward direction as well. So how I will write down in downward direction? Because here I have shown already the upward direction. Downward direction, that means I am going from V1 to V2. So the current would be Gm into V1 minus V2. This Gm is known as transconductance. Okay, transconductance. Mostly your answer in the examination will be given in the terms of transconductance. Okay, this is known as transconductance, but mostly in the examination you will not have to calculate this Gm, because if you need to calculate this Gm, then it will come from large signal analysis. Large signal analysis. So it might happen that you need to calculate this Gm as well, but in this video we are not learning this particular topic. We are only learning how to do the small signal analysis. So there is very high chance that in the examination your answer will be given in terms of Gm only. Are you getting this point? So this particular circuit was known as NMOS, and here you have seen this is gate, this is source, gate, source, V1, V2. Write down the current direction, and then there is a R naught present, which you can, which will not be shown in the examination, but you have to assume this R naught on your own. Okay, so we will come to this particular structure, but first let's solve some problem. First let's solve this question. What they are saying, VDD and Vx are the DC bias. You need to tell the small signal input resistance R in. This resistance you need to tell. So what you will do? First thing, VDD, DC bias shorted. So what I am gonna do in the examination, VDD is the DC bias, it will be shorted. Vx is the DC bias, it will be shorted. Now what I need to find? V in. If you need to find any resistance, what do you do? If I need to find any resistance from anywhere, from here I need to find V in. So what I will do? Here I will apply V in and get some I in out of it. I will apply some V in, get some I in out of it. So what will be my answer? My R in would be V in by I. Okay. But important point is, between this drain and source there is some R naught connected. this R naught is connected. So R naught is connected here. R naught is connected here. Where you are applying V in? Here you are applying V in. And where is your I in? I in is here. So I in is not the current in MOS. The current in MOS will be something different. I in is the current that is flowing here. Here there will be some different current that I don't know. Are you getting this point? Shall I make this circuit again? Okay. Let me make the circuit again on a bigger level. That here this guy is shorted. So from here to here I have R naught. And this is also shorted. Now what I am doing? I am applying a V in here and getting I in out of it. And my R in will be V in by I in. Okay. If this potential is V in and this current is I in. So here what will be the current? Certainly not I in. It would be something else that I can write down. We will certainly write down that current. So how we will write down the current? For writing down the current in MOS, which all two potential you need? This potential I need and this potential I need. I need these two potential. This potential and this potential. Do I have this potential? Yes, that is 0. Do I have this potential? Do I have the potential of this node? Yes, because V in will travel here. There is no resistance in between. Let's just say if this potential is V in. So what will be this potential? V in only, because there is no resistance in between. So if this is V in, this will also be V in. Now I need to write down the current. I can write down the current in upward direction as well, in the downward direction as well. Here this is V in, so I am writing down the current in upward direction. So what will be the current in upward direction? So if I am going upward, that means I am going from V into 0. So my current would be GM into, I am going from, current would be GM into, I am going from V into 0. V into 0. So GM into V in minus 0. So what will be the current? GM into V in the upward direction. Direction is very important. So current is GM into V in the upward direction. GM into V in the upward direction. What will be the current in R naught? Because what is my target? My target is to write down V in by I in. So I need this I in value now. So for that I am finding, because this I in will be divided in two paths. One path is this one, GM V in. Another path is this. So what will be the current in this R naught? The current would be this. What is this potential? V in. What is this potential? This is grounded, so this is 0. So what would be the current here? V in by R naught. Are you getting this point? Why I am doing so? Because what is my target? Target is V in, finding V in by I in. Are you getting this point? So I applied V in here. I got to know that in most GM V in current is there. In this resistance, V in by R naught current is there. So what did I get to know here is that my I in is equals to GM into V in plus V in by R naught. Right? So what I am getting? V in by I in. So my V in by I in would be 1 by 1 upon R naught plus GM. Right? So let's just say I write down this as 1 upon 1 by GM. Can I write it down? Say yes or no. Right? If two resistors are connected in parallel, R1, R2, and I write down their equivalent, what I can write down? 1 by R equivalent. This is equals to R in, right? This is equals to R in. This is equals to R in. So if I am writing down the equivalent, it would be 1 by R1 plus 1 by R2. Say yes or no. Right? 1 by R equivalent is equals to 1 by R1 is equals to 1 by R2. So what you can write down? R equivalent is equals to R1 parallel R2. Say yes or no. Right? R equivalent is equals to R1 parallel R2, or you can say 1 by R equivalent is equals to 1 by R1 plus 1 by R2. Now you let me know one thing. This is your R in, right? If I write down 1 by R in, that means R in goes here and this thing goes here. So what will be your 1 by R in? 1 by R in will be equals to 1 by R naught plus 1 by GM. 1 by GM. Because here there was GM, so I am writing 1 by GM. So 1 by R in is equals to 1 by R naught plus 1 by GM. So what is your R in? So R in is equals to 1 by GM parallel with R naught. Say yes or no. This is the answer. In the examination, it will not take this much of time. Believe me, in the examination, it will not take this much of time. This is very, very easy. Without even learning any model, without even learning anything, without even going into complexity, we are solving the problem. And with this concept, you will be able to solve any problem from MOS. Okay. What we are applying? First, we will write down what is our target. Our target is to find R in, V in by I in. V in, it is there. So Gm V in by R naught. So I in is equals to Gm V in plus V in by R naught. So V in by I in is equals to 1 by Gm parallel with R naught. Okay. So we will come to the conclusion. In the end, it will be very easy for you to write down. Okay, we will certainly come to the conclusion. But first, let's solve some problem. Then we can come to the conclusion. Let's solve this one. From here, I need to find I in. So one thing I forgot to tell you, that this gate always drives 0 ampere current. Okay, this gate always drives 0 ampere current. Whatever this current is flowing, Gm V2 minus V1, that is flowing from this MOS. From this gate, there will be 0 ampere current. From this gate, there will be 0 ampere current. So this current will be 0 ampere. Right? So now what I need to find? I need to find this R in. What will be this R in? R in will be equals to, what do we do? DC bias is shorted. DC bias is gone. This DC bias is gone. So what I will do now? Here there is R naught present. Here there is R naught present. Between these two guys, there is R naught present. There is R naught present. Between these two guys, there is R naught present. But DC bias is gone. So what I am finding? R in. What is my R in? V in by I in. Basically, I will apply a V in here and get I in out of it. I don't know what is my V in. I don't care about that. But I know that my I in is 0. My I in is 0. That means my R in is infinity. So looking from the gate, how much resistance do you see? That is infinity. And that is obvious as well, because the current is 0. This current is 0. If the current is 0, that means resistance will be infinity. Certainly, we will come to the conclusion. Don't feel like that, sir, I need to remember all these things. No. We will come to the conclusion and it will become very easy for you. Let's see this circuit now. What we need to find? We need to find again R in. So from here, I need to find R in. So what I'm going to do? I'm going to apply a V in here. I'm going to apply a V in here and get I in out of it. Say yes or no. And DC bias will be gone. This is a DC current. It will be mentioned in the examination, although the ID is a DC current, VDD is a DC bias. It will be mentioned. So this is a DC current. This will be gone. Now VDD will be shorted, but since the connection is broken here, since the connection is broken, so this is of no use. VDD will be shorted, but current source is gone. No. So connection is broken. So this is of no use. This VDD of no use. So I can remove this whole part now. Whole part is removed. So now this is my circuit. Okay. What is this node? What is my target? My target is to find R in. That is equals to V in by I in. What is this node? This node is V in only. Now between drain to source, there is R naught connected. Now this node is V in. Can I write down the current in MOS? Let me make R naught a bit far away. Okay. Can I write down the current in MOS? Yes. How I am writing down the current? I am writing down the current from V into ground. From V into ground, that means I am writing down the current from up to down. V into ground. So what will be the current? Gm into V in. Now what is my target? My target is to find I in. Now let me know one thing. Will this drive any current? Look, the circuit is this one. If you look it closely, this is the circuit. What did I tell you? That this drives 0 ampere current. That doesn't mean that this will also drive 0 ampere current. No. Are you getting this point? Here, this guy is driving 0 ampere current, but from here current can flow. Why is that so? Because this current will have another path, no? This I in current will see two paths. One is going into the MOS and one is this one. This current has two paths. The I in current got to know that the input of MOS, this will drive 0 ampere current. So I in has no other path but to go here only. Are you getting this point or not? A lot of guys do this mistake. They see from here, they will say I in is 0. No. I in has two paths. One is this one. Another one is this one. So I in will go here. So now I in again have two paths. One is this GMV in, and what is the other path? Other path is to go into R node. So what will be the current in R node? Think about it. If this node is V in, if this is V in, this will also be V in, 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 V in. This will also be V in. Say yes or no. V in will completely travel. So this node is also V in. If this node is V in, then this node is also V in. This node is V in, this node is ground. So what is the current here? V in by R naught. So what do you see here? I in is equals to I in is equals to GM V in plus V in by R naught. Have we seen this kind of equation before? Yes. I in is equals to GM V in plus V in by R naught. So what was our R in then? What was our R in? R in was 1 by GM parallel with R naught. Say yes or no. Yeah, sorry for the interruption because I was kind of feeling hot. Not hot like that. Hot means feeling the heat. Okay. Yeah. So where were we? We calculated R in. That was also coming out to be 1 by GM parallel with R naught. So first thing, you don't need to mug up these results. You can derive it in the examination, or we will write down the conclusion now. So let's see the conclusion. Mic is connected. Yeah. So this circuit is given and you need to tell R in value. So what you will do? Sir, I will apply V in and get I in out of it. This is what you will think in the examination. Sir, I in will be 0 only, because here if I apply V in, I in has only one path, that is there to flow from the input of the MOS, or you can say to flow from the gate. So gate will drive 0 ampere current, sir, and that's why my R in will be infinity. Very easy. Here also, sir, I will do the same thing. I will apply V in, I will get I in out of it. But sir, now this I in has two paths, one to flow from the gate, other one is this path. In the gate there would be no current, so the next path would be this one. So this I in will follow this particular path. Now the thing is where this I in will go. So I in can go into this MOS as well, and there is one R naught is also connected, which we cannot see. R naught is also connected there. Where it is connected? Between drain and source. R naught is connected between drain and source. Now let me know one thing. Where the source is connected? Source is connected to ground. Now my job is to connect this particular node to source. But source is connected to ground, no? Source is connected to ground. So can I connect it like this? Directly I am connecting it to ground. Because source is already there at ground, so I can make it to the ground as well. Let's just say if your source was connected to some network. It was connected to some network. And then this network was connected to ground. So then you cannot do this thing. Then you will have to connect this particular node to source only. But now your source is connected to ground. So at a lot of places or during the analysis as well, I will also do the same thing. If I see source is at grounded, then between drain to directly to ground I will connect it. Because this is grounded, so this is also grounded, right? So now this V in will be traveling here, this V in will be coming here as well, sir. Now since this is your V in, so I can write down the current in MOS, that would be, sir, GM into V in, sir. Now this I in has, sir, two current component, that one is GM V in and another one is V in by R naught. This I in will have, sir, two component, GM V in and other one is, sir, V in by R naught. If you have written down this equation, then you would know what is your answer. If this equation is coming, then you know that my R in will simply be 1 by GM parallel with R naught. Okay. So what do you think? What will be the unit of GM? What will be the unit of GM? What do you think? GM, 1 by GM is a resistance, right? 1 by GM has a unit of resistance, that is ohm. So GM unit will be Maho, right? So just for the knowledge I am telling, because here my target is just to tell you how to solve the problem in the examination. That's it, nothing else. Comprehensively I teach this topic in 45 hours. Okay, recorded lectures are 45 hours for MOSFET, because that is a very important topic. But since the examination is near and I know a lot of people skip this topic, because this is taught for roughly around 4 to 5 hours everywhere. I don't know why, but this is very important. Since it is very important, that's why I am taking it. I will take all the possible example, don't worry. Okay, and certainly you will be able to solve the problem in the examination. Sure you will be able to solve it. What about this circuit? Have we seen this circuit? Yes, this was our first circuit only. This was the first circuit only. Here what was the scene? Both were grounded. So what did I do here? Here your gate was also grounded and drain was also grounded. Gate and drain both were grounded. Here what did I do? Here also both are grounded only. Here also both are grounded only, but I connected both of them and then I connected a ground. Both are grounded only. And let's just say you forget it everything. You forget everything. What you are going to do? One thing you know, I need to find R in. What I'm going to do? Apply V in, get I in out of it. One thing I know, that here there will be R naught connected, right? The other node of this, one node of this R naught is connected to V in, one node of this R naught is connected to source, and source is connected to V in. Other node is connected to drain, and drain is connected to ground. So can I make it something like this? Other node is directly connected to ground, so can I connect it to ground? Yes. Now what you can see, I in will have two components. One will be going into MOS, another one will be going into R naught. What will be the current in R naught? From V in you can see the current is going V in by R naught. And from V in the upward direction, what will be the current? Gm into V in. So two component, Gm into V in and V in by R naught. So what will be your R in? R in will be 1 by Gm parallel with R naught. This will be your R in. So I will remove all this off. Okay, I will remove all this off because here I need to tell you one conclusion. So now let's see a very interesting thing. So what I can say, look, this is a particular structure now. So this particular structure I can call as 1 by Gm. This is just a rough way of telling it that wherever I see the arrow, so this much portion I am calling as 1 by Gm. What do I mean by that? What is this? This is our source, this is our gate and this is our drain. So I will say that from source to gate I can see 1 by Gm. From source to gate I can see 1 by Gm. What I am saying, from source to gate I can see 1 by Gm resistance. Now gate is connected to drain. And drain is grounded. Here from, what did I say? From source to gate, what do I see? I see this arrow. So from source to gate I see 1 by Gm. Now this gate is connected to drain and drain is grounded. So from source to ground I see 1 by Gm. Do you agree to this point? Are you getting this point? Now sir, now you will say that, sir, can I apply this concept here? No. Why is that so? Because you are not even looking from the source. You are looking from gate here. So here you will do the same analysis. Here also you can do the same analysis that I have taught you. But just for the shortcut purpose I am telling. If you are looking from the source, whenever you look from the source, there is a shortcut. What is that shortcut? That always you can say that from source to gate I can see 1 by Gm. Do you agree to this point or not? Okay, whenever you are looking from source, because in a lot of circuit, like in analog electronics as well, like in 90% of the circuit you will have to look from the source. So whenever you are looking from the source, that's why I am telling this conclusion, this shortcut I am telling. So whenever you are looking from the source, you can say that from source to gate I can see 1 by Gm. Here gate and drain both are connected to each other. So I can say that from source to drain as well I can see 1 by Gm. Now since drain is grounded, so from source to ground I can see 1 by Gm. Now another thing can I tell, from source to drain I can see R naught. What I am saying, from source to drain I can see R naught. And drain is connected to ground. So from source, how much resistance I can see? So what I will say, sir, from source to ground I can see, 1 by Gm. From source to ground I can see R naught. So basically from here, how much resistance I can see? R naught parallel with 1 by Gm. There you go. Say yes or no. Will you be able to tell it? Certainly you will be able to tell it. Right? Okay. Well and good. No issue about it. So a very good point it is. So let's keep it here. Arey yaar, chala gaya. So I will just make it source R naught, source to gate. Here I am writing 1 by Gm, and this I will write source to drain. That is also 1 by Gm. So here I am calculating. So although the drain is grounded, here also the gate is also grounded. So from source to ground I can see 1 by Gm parallel with R naught. And this is what you need to find. What is my R in? R in is the resistance from here to ground. Look, whenever I tell, if I ask you this question, that what is your R equivalent? So only at that time you can say R equivalent is, let's just say this is R1, this is R2. So you can say R equivalent is R1 parallel with R2. Only when both are connected to ground or both are connected to each other. Let's just say both are connected to each other. R1 is connected to R2 and they are connected to another resistance. And then this is connected to ground. So always there is a ground. So what you will say, what is your total resistance? That's R1 parallel with R2 plus R3. So these two are providing you R1 parallel R2 plus R3. That would be your answer. So same thing we are doing here. Looking from the source, I need to find the resistance. So from source to ground, I need another resistance. One resistance I need from source to ground, another I need from source to ground only. So from source to ground, I get 1 by Gm. From source to ground, I get R naught. So from source to ground, the resistance is 1 by Gm parallel with R naught. Say yes or no. Well and good. Okay, yeah. So we will use this thing again and again. So there you will learn it in a better manner. So when you go into the video, you will certainly learn all these things. Your target is just to watch it and keep on doing the work in your rough notebook. You should not make any notes. Just keep on doing the same thing in your rough notebook. Certainly you will be able to solve the problem in the examination. Let's get started. Do this question on your own. Okay. You need to find the value of Rin. I will take a pause. You try doing this question on your own. How will you find Rin? This IDC and VDD both are the DC bias. So what will happen? This will be gone. Now find Rin. You should be able to find it. Same thing we need to do. Apply V in, get I in out of it. Target is V in by I in. So now get the relation of I in terms of the known factors. Try doing it. Yeah. So how we will solve it? What we are going to do? V in, get I in out of it. What will be your R in? If you have just solved it, then just skip this. Okay. Just quickly skip that to the next 1 or 2 minutes, because here I will be solving it, and just see if your answer matches or not. If your answer is not matching, then see the solution. Otherwise, go to the next one. So in that manner, you can save your time. That's why I ignore taking the session live. If I have taken the session live, then you would not be getting any, like, your time would be wasted if you see it live. But if you watch it recorded, you can quickly skip to the part which is required for you, right? What I need, V in by I in. So what I know is that there is between drain to source. Source is connected to ground. So between drain to ground there is R not connected. Drain to source it is connected, but source is connected to ground. So from drain to ground there is R not connected. So what will be the current in this R naught? That will be V in by R naught. And if I am making the resistance here, then I need to show the current here. This will be my I in. Are you getting this point? So this I in is from drain to ground there is R naught. So how much current is flowing this R naught? That is V in by R naught. And if this node is V in, then this node will also be V in, because this V in will travel here. So how much current will be flowing into the MOS? That current will be GM into V in, right? Because I am writing down the current in MOS. GM, I am going from V in to ground. So current will be GM into V in minus 0. So current will be GM V in. So what is the factor? I in is equals to two currents. One is flowing in the R naught, that is V in by R naught. And another current is GM V in. So what will be your R in? This equation I have already seen. So R in will be 1 by GM parallel with R naught. Within seconds you will be able to tell the answer. Luckily we are getting these answers again and again. That doesn't mean always the answer will be 1 by GM parallel with R naught. It would be different as well. We will slowly build the toughness level of the problem. Tell the answer of this one. Again do the same thing. What do I know? This thing I know, right? That between drain to source there is resistance R naught. Now can I connect this R naught to ground? No, because my drain is not connected to ground. Drain is connected to resistance R. So this R naught should also be connected to resistance R only. Say yes or no, right? Now this VDD I can take to ground. VDD I can take to ground. What I need to find? I need to find this R in. That means what I will do? I will apply V in, get I in out of it. So my target is R in, that is V in by I in, right? So what I can do now? Can I write down the current in MOS? First we will solve it, then I will tell you a conclusion as well here. So first we will solve it. So can I write down the current in MOS? For writing down the current in MOS, I need this potential and this potential. Do I know this potential? No. In the previous questions, I was always knowing this potential. It was connected to ground only. But now this is connected to resistance R. So do I know this potential? No. So what I will do? I will assume a potential here. I have to assume a potential, that is V. So what I have assumed? I have assumed a potential V here. Okay. So can I write down the current in MOS? Yes. How I am writing down the current in MOS? I am writing down the current in MOS in upward direction. So current in the MOS will be GM V in minus V. If I am writing down in the upward direction, GM V in minus V, that will be the current. Now this V node reaches here as well. So what will be the current in this R node? The current in this R naught will be V in minus V by R naught. Say yes or no. That would be equals to I in. Do you agree to this point? I in has two paths again. One to flow through this MOS and another one to flow this R naught. So through this R naught, how much current is flowing? V in minus V by R naught. And through this MOS, how much current is flowing? GM into V in minus V. Because I am writing down the current in upward direction, so V in minus V. So that is the equation. But what is the issue here? The issue is this V potential, because what is my target? To get the relation between V in and I in. So issue is this V potential. So I need to get this V potential in terms of I in or V in. So what do I see here? From V in, I in current is flowing, right? That is being divided into two paths. Now what will happen? These two current will again come back. These two current will again come back, and then both will be added. So how much current will be this? If you are not understanding by this particular analysis, so let me show here. I am saying one current is flowing I in from here. Now these are the two current. One is I1, one is I2, right? These are the two current sources. Now if I ask you what is the current in this resistance R, what will be that current? That current will be I1 plus I2. I1 plus I2. Now what is this I1 plus I2 equals to? That is equals to I in only. Because from downward I in current is coming, that is being divided into two paths, then again added. So from R, how much current is flowing? I in only. Say yes or no. Are you getting this point? Right? So all the current will be added, and then that is flowing from R. So certainly this current will also be I in only. Getting this point? Right? So in the resistance, I in current is flowing. So can you let me know what will be this drop? The current is flowing from V to ground. What will be this drop? That will be I in into R. Right? So what will be the value of V? The value of V will be I in into R. Say yes or no. Value of V will be I in into R. Because if this node, let's just say, this is very simple network analysis, but if you don't know these concepts, then it is very tough for you. The current is flowing like this. If the current is flowing upward, what does that mean? What will be the drop? This will be the drop. So let's just say this current is I in. So what will be the drop? I in into R. So if this node is grounded, 0 volt. So what will be this node? From here to here if you are coming. So this node will be positive. So positive will be I in into R. The issue will be the direction. Issue will be with the direction or positive or negative sign. So it will be positive. I in into R it will be. Why is that so? Because 0 is a negative. So from 0 to something you are getting. From 0 to towards positive side you are getting. So that is I in into R. Or you can write down the current as well. I in into R minus 0 divided by R. That will be I in from in the upward direction only. So I hope you are understanding these kind of points, which are very basic network analysis. It is right. So I in. Okay. So another relation that I got is this one. That V is equals to I in into R. So here can I put I in into R? Yes. I in into R plus V in minus I in into R divided by R naught is equals to I in. Okay. So now what you can do? So Gm plus 1 by R naught into V in is equals to I in into R by R naught plus 1 plus GMR. Look, this is a very strange kind of expression we are getting, and we are not going to get anything good from it. So whatever the expression you get from here, you will get R in. So that will be equivalent to what? Can I write it down without any equation? Yes, I can write down. How? What did I tell you? From source to gate, how much resistance do you see? 1 by Gm. What did I tell you? That from source to gate, how much resistance do I see? From source to gate, the resistance I see is 1 by Gm. So from source to drain, how much resistance I will see? R naught. From source to drain I see R naught resistance. Now drain and gate both are shorted or not? Yes, both are shorted. Drain and gate both are shorted. This was our drain. This was our gate. From source to gate I see 1 by Gm. From source to drain I see R naught. And gate and drain both are shorted. Now the node of gate is connected to R. Sorry, node of gate you can say, or node of drain you can say. Drain is connected to R. Drain is connected to R, and that R is grounded. Is this the circuit or not? Say yes or no. Where I am looking from the source. So from source to gate I see 1 by Gm. From source to drain I see R naught. Drain is connected to R and R is connected to grounded. Is this the circuit? Forget about this drain, gate and source now. From where I am looking? I am looking from here. So what will be the resistance? 1 by Gm parallel with R naught plus R. Do you remember the example that I showed here? Right? The same kind of circuit we are getting here. Analog electronics is just network analysis only, but here we use devices, nothing else. Okay. So without even getting these kind of complex equation, this is what I wanted to tell, and from the equation we are not getting anything good. But in the examination, what kind of option will be mentioned? The option will be mentioned in this manner: 1 by Gm parallel with R naught plus R. This is how the option will be mentioned in the examination, because they want you to think in this manner, that from source to gate I see 1 by Gm, gate is connected to drain. So source to drain I also see R naught. So R naught is coming parallel to 1 by Gm, then that is connected to R. So 1 by Gm parallel with R naught plus R, that will be the answer. Are you getting this point? Say yes or no. Okay. Solve this question. R naught is infinity here. What they are saying? R naught is infinity. That means whatever the resistance here we got, this resistance here we got, no? So that is infinity. Infinity means open circuit. Basically R naught is not there. This is what they are saying. They are saying that R naught is not there. This is what they are saying. R naught is infinity means R naught is not there. Other way of showing it, they will say that there is no channel length modulation. What they will say? There is no channel length modulation. If they say this thing, now I cannot tell you what do you mean by channel length modulation. In the examination, you just need to understand if they are saying that there is no channel length modulation, or they can say lambda is equals to 0, or they can say R naught is infinity. All three are same thing. What does that mean? That you will not connect any R naught here now. So now this equation becomes very easy for you. How this is becoming very easy? Because what do you need to find now? R in you need to find. That means you need to apply V in here and get I in out of it. In the previous problem, I in was having two paths. Here also I in was having two paths. But now I in will have only one path, and that is to flow through MOS. So this I in will be flowing through MOS. This Vx1 is a DC bias. This is gone. VDD is a DC bias. This is also gone. This is gone. And this is also gone. So what do you think? What will be the current in the MOS? The current in the MOS in upward direction will be what? Gm into V. Say yes or no. The current in the upward direction in the MOS will be Gm into V in only. And here what you are having? Here you are having V in. So from V in to 0 you are going. That means the current is Gm V in minus 0. So current is Gm V in. That is equals to I in only. Because R naught is not there. So Gm V in is equals to I in. So what is your R in? My R in is V in by I in. That is equals to 1 by Gm. There you go. Say yes or no. Is that okay for you? Very easy question now, right? Let's go to the next one. Or how you can say that, sir, from source to gate, sir, what do I see? 1 by Gm, and gate is connected to ground. From source to gate, I see 1 by Gm. From source to gate, I see 1 by Gm, but gate is connected to ground. So from source to ground, how much resistance I see? 1 by Gm. Now you will say, sir, what will happen to this R? Does that matter to you? No, it doesn't matter. Like wherever this R is there, I don't care. But one thing I can see that from source to gate, from source to gate, I see 1 by Gm, and gate is connected to ground. So from source to ground, I only see 1 by Gm, nothing else. From source, there is only one branch going in. That branch is this one. From source, there is only one branch. That branch is this one. And this branch is 1 by Gm. So from source to ground, I see 1 by Gm. I don't care what will happen to this R. But if I am looking from the source, I can see one thing, that from source to gate I see 1 by Gm, and gate is connected to ground. That means from source to ground I see only 1 by Gm. Answer is 1 by Gm. Just by looking at the circuit, I will write down the answer in my examination. Say yes or no. Okay. Let's go to the next one. Did you understand this one as well? This was also pretty good. Here the thing I told you, from source to gate, and gate and drain are connected. So from source to drain I see 1 by Gm, from source to drain I see R naught, from drain to ground I see R. So this is how I can write down the resistance. Okay. Sorry for the interruption, because I was again feeling cold. Okay, yeah. So now let's see this circuit. So in this circuit, you need to find the value of R in. A very good circuit, a very standard circuit as well, and very important for your examination as well. So can you say that, sir, from source to Vx will be grounded? Let's make the small signal circuit. The small signal circuit will be VDD will be grounded. This is the resistance R, and from here I apply V in, and this node is also grounded. Okay, and then there is R naught present as well, because this time R naught is finite. Now R naught is not infinite, R naught is finite. What I will do, I will apply V in and get I in out of it. So can I say, sir, now from V in to ground, or I can say from source to drain IC 1 by GM, or I can say from source to ground IC 1 by GM. There is no issue about that. But is that the only resistance you see? From source side or from V in, do you see only 1 by GM till the ground? No. From source till the ground, you do not only see 1 by GM, because from this V in there is this R naught is also connected. No. The thing is, here there is source. Here you see 1 by GM, that is connected to ground. But now here the scene is R naught is also there. This R naught is also there. And previously when we saw this particular circuit, these two nodes were connected to each other. That means source and drain were connected to each other. Both of them will be connected to each other. There I saw 1 by GM as well, there I saw R naught as well, but both were connected to each other. But here what is the case? This guy and this guy is not connected to each other. Right? And can you say that, sir, directly this R naught, this R resistance is connected to R naught? No, this R resistance is connected to MOS as well, and it is connected to R naught as well. Previously, what I could have said that, sir, my resistance R is connected to drain as well and source as well. My resistance R is connected to drain as well and source as well, and both are connected to each other. So this circuit was okay. This circuit was fine for me. But now, if I say that, sir, from where I am, yeah, here I am. So, sir, if I say that, sir, from drain to ground I see resistance R, will that be okay? No, because what R will say? R will say that, sir, I am connected to drain as well and another MOS as well. In the previous circuit, in this circuit, R was saying that, sir, I am connected to drain and I was connected to gate, and both are connected to each other. But here R will say that, sir, I am connected to drain and connected to MOS. Basically, R will say that I am connected to drain only, and drain will say that, sir, I am connected to R naught and I am connected to MOS. In the previous question, the drain was saying that I am connected to gate only. So now the small signal, that circuit, that will not work now. So you have to do the analysis. Are you getting this point? That shortcut is not working. Basically, if I see the conclusion here, if both are connected, then this particular configuration will give me 1 by GM parallel with R naught. I can say that from source to gate I can see 1 by GM, and gate is connected to drain. So from source to drain I see 1 by GM, from source to drain I see R naught as well. So basically my R in would have been 1 by GM parallel with R naught will be given by this much configuration, and then in series there will be R. In series there will be R. This would have been the answer. But now this is the scenario. Here drain and gate both are not shorted. So now you need to do the analysis. What kind of analysis? Let's remove this off. Okay. So can I write down the current in MOS? Yes, I can write down the current in MOS. Let's remove this drain as well. What will be the current in MOS? That will be GMV in. So current in MOS will be GMV in. GMV in. What will be the current in this R naught? That I don't know, because the current in R naught will be V in minus this potential. Let's just say this potential is V, but I don't want that. In the previous question, in this question, I wrote down this V potential, but I don't want that. I'm not gonna introduce any new variable now. So what I'm gonna do, I know one thing, that from V in I in current is going, and this I in current is divided into two paths, then both of the currents are added and it will be flowing through R. So if someone will ask you what is the current through R, that will be I in only. Right? I in current is going, that is divided into two parts and then again added back. So through the resistance R, how much current is flowing? I in only. So what will be the drop here? What will be the drop here? I in into R. Look, I could have introduced another variable as well, but the thing is I don't want to introduce any other variable. So I just want to solve my problems in terms of V in and I in only. And believe me, in the examination you will be able to solve. Okay. So I have reduced down my complete circuit in terms of V in and I in only. So this node is I in into R. And why I need the potential of this node? Because my I in will depend on the current in R naught, and R naught will depend on the potential V in as well and this potential as well, which is equals to I in into R. So that's why I need this particular potential. So can I write down the KCL now? Yes. So my I in will be equals to the current in MOS that is going upward. What is that current? GM into V plus what will be this current in R node? That would be V in minus I in into R divided by R naught. So what you are getting? I in into this goes here. So R naught plus R divided by R naught is equals to GM V in. So what is your R in? Here it is R naught only. So V in by I in I need to find. So क्या कुछ गड़बड़ हुई है यार? No. Okay, fine. R naught plus R divided by 1 plus GM R naught. So this is the answer of R in we are getting. What answer we are getting? R naught plus R 1 plus GM R naught. You need to remember this answer. If it is possible, then remember it. Otherwise, at least you will be derived in the examination. But if you remember it, then it will be very good. Where I am going? I am going from source. I am looking from source. Looking from the source, how much resistance I am getting. Looking from the source, how much resistance I am getting. So how will you remember? First look from the source. This is just a way of remembering it. This is not any intuition, nothing like that. Just a way of remembering it. Okay, just a way of remembering I am telling. So looking from here, what do you see? These two resistance, just assume them in series, R naught plus R divided by something. So this factor GM R naught, that you will be remembering like 100%, because now we are going towards, now we are writing down what we are writing down. We are writing down the input resistance. But when we will go towards the gain, so at that time you will be certainly remembering this term. This term is very easy. GM from here, R naught here, GM into R naught. So if you remember it, then it is pretty good. Otherwise you can derive in the examination as well. Usually people remember this particular resistance. What I am asking, like I am not saying common source, common drain, these things I am not saying. Okay, this particular structure is known as common gate. Why it is common gate? Because gate is grounded, no? So it is known as common gate structure. But that will not be asked in your examination. In your examination, what you need to do, they will ask you resistance or gain from a particular node. So these kind of analysis you can do. Otherwise, if you want to remember the answer, then also you can remember the answer, because it is a standard circuit. Okay, and what is the way of remembering? R naught plus R divided by 1 plus GM R naught. Okay, but just remember one thing, because this option will also be there. This option will also be there. So don't do this mistake. The point is, both are not connected to each other. If both are connected to, and in this example as well, this option will also be there, because IITs know that people remember this answer. And what students will do? Okay, we are looking from the source. What is the answer we remember? If R is connected, so R naught plus R divided by 1 plus GM R naught. Wrong. That will also be wrong. So you just need to keep your concentration high. You need to give your full concentration that what is happening. Drain and gate are connected to each other or not. If they are connected, then 1 by GM parallel with R naught plus R. If they are not connected, then R naught plus R divided by 1 plus GM R naught. Okay, and here in a lot of example we are getting 1 by GM in a lot of example we are getting this thing as well, no? 1 by GM parallel with R naught. Now in the examination this option can be mentioned, or the final answer can also be mentioned. How you can reduce 1 by GM parallel with R naught? How you can solve it? 1 by GM into R naught upon 1 by GM plus R naught. So what you are getting? R naught upon GM R naught plus 1 RE. So this answer also can be there. Okay, or this answer can also be there. So the same kind of answer here also you are getting. Here also R naught upon 1 plus GM R naught, just R is also there. Okay, so what you are getting? What will be the answer here? Here the gate is grounded, but drain is not connected to gate. So your R in will be R naught plus R divided by 1 plus GM R naught. Okay, and what about this one? Here what we are saying that R naught is infinity. Then no matter whatever the network is there, I don't care about that. One thing I know that from my V in to ground, I only see 1 by GM. That's it. So my R in will be equals to 1 by GM. Are you getting this point? So these three different circuits are there. These three different answers are there. I hope this is also clear to you. Now just see one thing. What was the R in we were getting? R naught plus R upon 1 plus GM R naught. Now what is the difference between these two circuits? No difference is there. In place of this resistance R, can I use any network? Yes. No difference is there. The only difference is this R0 is infinity. That means in this circuit, in this particular circuit, if I put R0 equals to infinity, in this particular formula, if I put R0 equals to infinity, if R0 equals to infinity, so what will happen? R0 plus R, that means R0 is very large. R0 is infinity means, let's just say it is some this much and R is some 100. So can I reduce R0 plus R equivalent to R0 only? Yes, because R0 is very large. What is this GM R0? Plus 1. Since R0 is very large, that means this quantity is also very large. R0 is very large, that means this quantity is also very large. So I can ignore 1 as well. So what I am getting? R0 divided by GM R0. So what I am getting? 1 by GM only. So this circuit and this circuit both are same only. If R0 is infinity, you are getting the same answer. But in the examination, you will not be doing this much analysis. That you put R0 equals to infinity. Here, there, you will just be seeing that from V0 to ground, I see only 1 by GM. That will be your answer. Right? But I am just telling you that all things are interrelated. And all these things are very confusing. Student can do minor mistake anytime. If IITs want to frame a very good question, then they will frame the question like this. Are you getting this point? Okay. And my target is just to teach you right from the zero, even if you haven't studied anything, to the point. If they are asking very tough questions as well, then also you will be able to solve. Basic question everyone will be able to solve, but those who have studied it comprehensively, believe me, they will also not be able to solve this particular structure. Right? In this circuit as well, they will do some minor mistake. So we are seeing everything. That's why it may take some time, but again, you will be very confident in the examination, because that is very important for your upcoming examination. This particular topic is very important. Let's solve this one. Try thinking about it. Look, where I need to see the circuit from, where I need to see the R in from downward here. From source I need to see. So whenever I need to see from the downward, in the previous example, here I was already getting R. So my concern was not to look from here. Like I knew one thing, that upper side I only see R. Are you getting this point? But here R0 will be connected, right? But on the upper side as well, you see another circuit. So that circuit also you need to solve. So always start the circuit from the top. Let's just say from here I need to find. So I will start the circuit from here. If I needed to find the resistance from here, then I would have started the circuit from bottom. Are you getting this point? If I am looking from here, then I will start from here. If I am looking from here, then I will start from the bottom. So one by one, step by step, I will go. Are you getting this point? Okay. So let's make the equivalent circuit first. VDD will be grounded, VX1 will be grounded. This will be mentioned in the examination that both are your DC bias. Or in the examination, it can be mentioned that VX1 is a small signal. What I am saying, in the examination, they can say that VX1 is a small signal. Then also it will be grounded only. Because what we are finding? We are finding Rin. Whenever you find the Thevenin resistance, what do? Everything is gone. Current source is open circuit, voltage source is shorted. So even if they say that this is your small signal voltage, then also it will be shorted. All the voltage sources will be gone. Whether it is small signal, large signal, everything will be gone. Condition that you are finding Rin. So if your Vin is not in use, then that will also be shorted. So here in place of Vx1, if I write down Vin1, which is a small signal, I am saying that this is a small signal, then also it will be shorted only. Okay. This will be shorted only. And then VDD will also be shorted. Both are shorted. So can I connect them to each other? Yes. I can connect them to each other. And then I can say that both are connected to ground. Say yes or no. Right? Then downward I am getting this circuit. Both are connected to each other. And they are connected to R0. And from here I am looking. Right? Here also there is a R0. Say yes or no. This is connected to ground. But can I say from source to drain there is a R0, and this drain is also connected to ground. Say yes or no. Is this the equivalent circuit? Are you agreeing to this point? Yes. So what did I say? If I need to start from the bottom, I will start solving from the upward side. So my point is, from here I will look. that from here to upward side, how much resistance do I see? That means now I need to replace this much of circuit. Because if I have replaced this much of circuit, then half of my job is done. Are you getting this point? How I can replace this much of circuit? I know that from here to ground I see 1 by Gm, and from here to ground I see R naught. That means 1 by Gm is parallel with R naught. Are you able to understand this point? I am replacing the circuit from here. So what I will say, from source to ground I see 1 by Gm, and from source to drain, or I can say from source to ground I see R naught as well. So this particular circuit can be replaced with 1 by Gm parallel with R naught. Do you agree to this point or not? So how I have reduced the circuit? So from this source to ground, what do I see? 1 by Gm parallel with R naught. Say yes or no, right? Okay. Now what is the scenario? This is the scenario, and there is also R naught. This was not my target. My target was to find the resistance from here. So now if I look from here, what I can see? How much resistance this will offer? How much resistance this much configuration will offer? What I can say? My source is from source to gate. From source to gate, what do I see? 1 by Gm. From source to drain, what do I see? R naught. And gate and drain are shorted to each other. That means from source to drain I see 1 by Gm, from source to drain I see R naught as well. That means how much this is to offer? 1 by Gm parallel with R naught. This we have already seen. How much this thing will offer? 1 by Gm parallel with R naught, and that is in series with R. But now what is the scenario? How much thing this is offering? 1 by Gm parallel with R naught. That is in series with 1 by Gm parallel with R naught. There you go. And in the examination, what may happen is that they can call it M1, they can call this one as M2. So this will be R naught, sorry, this will be R naught 2, this will be R naught 1. So this will, I am going to write down as 1 by Gm2 R naught 2, and this is your R naught 1. So this will offer you 1 by Gm parallel with R naught 1. So what is the scenario now? This is your ground. Just a second, why this handwriting is not coming that good? I don't know what is the reason. Yeah, so what is the scenario now? That 1 by Gm2 parallel with R naught 2, and this much is offering you 1 by Gm1 parallel with R naught 1, and from here you are looking. So from here to ground, what do you see? Your Rin is equivalent to 1 by Gm1 parallel with R01 plus 1 by Gm2 parallel with R02. There you go. This is what you will see. Say yes or no. Right? Very good question it was. In the examination, it will not take me any time, because now I know the process. Looking from downward, I need to solve the upper circuit first. So what I will see, sir, 1 by Gm2 parallel with R02, and so this much circuit will give me 1 by Gm2 parallel with R02. Then downward I will see here, okay sir, this much circuit will give me 1 by Gm1 parallel with R01. So 1 by Gm1 parallel with R01 will be in series with 1 by Gm2 parallel with R02. So without even drawing the circuit, if I have enough practice, although you don't have enough time for practice, but if I have studied this particular topic only, then also I will be able to write down the answer. Say yes or no. Okay, well and good. So this is the other way of solving it. Now I guess the example will be from, okay, next example will be from PMOS. So first let's solve this question. What do you need to find? You need to find V naught by V in. This is what you need to find. You need to find the voltage gain, small signal voltage gain. So how will you find that? Again, there is certainly R naught connected. So from here to source, from drain to source, R naught is connected, but source is connected to ground. So can I make it like this? Yes. VDD will also be grounded. VDD will also be grounded. So can you say one thing? Can you say one thing? Can you make the circuit again? How will you make the circuit again? This is grounded. This is your V in. This is your V naught. So from V naught to ground, what is connected? R naught. And from V naught to ground only R is also connected. No? Both of them are coming in parallel only. So can I reduce it to one circuit only? Can I reduce it to one resistance only, and can I call it R naught parallel with R? Say yes or no. From V0 to ground there is R, from V0 to ground there is R naught. So both are in parallel. From V0 to ground there is this MOS as well. In between there is MOS as well. So how much current will be flowing in this MOS? If this node is V in, this is ground. So can you tell what is the current? Yes, that will be GM V in. Can you apply nodal at V0? Yes. What will be nodal at V0? V0 divided by, now you will not say that sir from V0 I will assume a I0 current. No, nothing like that. From V0 you will assume a I0 current if you need to find the resistance. But here I am finding the gain. Here this V0 was just nothing. This was just an open end. It was nothing. I just gave this node as V0. Let's just say, if I ask you this question, that this is your 2R, this is your 2R, this is your 4 volt. What is the potential here? What is the value of V0? You will say 2 volt. Will you say that sir I will assume I0 current here? If you assume any I0 current here, then the answer will not be 2 volt. Because what we assume is that all the current is flowing in the 2R as well, there is same current, in 2R as well there will be same current. Then also you can say there is 2 volt, no? So I just assume a V0 node there. That doesn't mean you will say that sir there is some I0 current. No. Previously we assumed the current, here we assumed the current because we are finding R in. But here we are finding the gain. So in the V0 there is no current, nothing like that. These are basic thing of network analysis that I am telling. Very basic thing, right? So if I assume this is my V0, so what will be the current in this branch? That will be V0 upon R0 parallel with R plus GM V in. That would be equals to 0. This is how I can apply the nodal, right? So what do we get? V0 by V in is equals to minus GM R0 parallel with R. That's it. What I will be doing in the examination, I will not be writing on this step. What do I know? That this current is GM V in. Now this current has how much path? This GM V in, this is one circuit, okay, which is connected to ground, and then there is some resistance R. This current GM V in, this current can flow from here, and then it will have to flow from here. Are you getting this point? The current has to flow in the loop. This GM V in has to flow in the loop. Why is that so? Because the current cannot go here. Here the current is 0 ampere. So the current cannot go here. The current has to flow in the loop. So what will be the current? Current has to flow in the loop. So how much current is flowing through this resistance? This is the resistance which is R0 parallel with R. And this is your V0. So how much current is flowing through this resistance? That is GM V in. And if the current is flowing from down to up, then how will be the voltage drop? This is how will be the voltage drop. And this is at the negative node. So what will be your V0? V0 will be minus R0 parallel with R into GM V in. Voltage will be current into resistance. So voltage will be R0 parallel with R into GM V in. So what will be your V0 by V in? That will be equals to GM R0 parallel with R and minus sign. That will be your V0 by V in. So this is how I will be solving the examination. Are you getting this point? Like n number of ways are there. Just I am telling you all the possibility which you can use in the examination. Let's see this circuit. So have you seen this kind of device? No. Till now we were seeing that arrow was outward only, right? So this was our NMOS. Now we are going to see PMOS. So let's get back to the first slide now. Here. So this is known as PMOS. Okay. This is known as PMOS. Arrow is inward. In NMOS, the arrow was outward. Now the arrow is inward. Okay. Yeah. So wherever there is arrow, that is known as source. The middle one is known as gate. Rest will be drain. Wherever there is arrow, this is known as source. Middle one is known as gate, and this will be your drain. Say yes or no. Any issue about that? Why I am writing it again? I'm not sure. Okay, same thing is there. Ditto same thing. No need to worry. Between source and drain, how much resistance is there? R naught. If this potential is V1, if this potential is V2, can you write down the current in MOS? Yes. What will be the current? Do you care about this potential for writing down the current in MOS? No, I don't care about this potential. Whatever the potential is there, the current in the MOS is decided by these two guys. So what will be the current? If I am writing down the current in downward direction, what that would be? Gm V1 minus V2, because I am coming from V1 to V2. If I am writing down the current in upward direction, what that would be? I am going from V2 to V1, so that would be Gm V2 minus V1. There you go. Same D2 analysis is there. Exactly the same analysis. Are you getting this point? So you are not learning anything new here. Now just the device has changed. Rest all property are same only. Okay. So let's get back to our circuit. So what we need to find? We need to find Rin. So in the examination, what I'm gonna do? First, I will make the circuit, small signal circuit I will make. How I will make the small signal circuit? That sir, these two are connected to each other. And sir, from here I need to find Rin. That means I need to apply V in and get In out of it. One thing I know that sir, VDD will be grounded, but from here to source to drain, there will be R0 resistance connected. And since this is grounded, so I can connect the R0 resistance directly to ground. Okay. Now, can I write down the current in MOS? Yes, because if this node is V in, then this node will also be V in. So current in MOS will be from V in to ground if I am writing down. The current in the upward direction if I am writing V in to ground. So what will be the current? So the current will be Gm V in the upward direction. And what will be the current in R0? So that would be V in by R0. So this will be equals to In. So what I am getting? My Rin is equals to 1 by R0. Sorry, 1 by Gm parallel with R0. So this is my Rin. Or what you could have done, let's just say I am not comfortable with PMOS. So what I will do, I will make the same circuit for NMOS. Although this is a very bad approach, but still I am telling you. Let's just say I am not comfortable with PMOS. Although you should be comfortable, there is nothing different. But what I could have done, that sir, I will make a PMOS now. Sorry, I will make a NMOS now. Now here, what was the scenario? That this arrow was connected to VDD. This arrow was connected to VDD. In small signal, that was connected to ground. Okay. Connected to ground. Now, drain and gate are shorted. Drain and gate are shorted. And from where you are finding out the resistance? From drain. So from Rin. This thing and this thing will give the same result. Do you remember this circuit we have already seen? What was the Rin? Here you will apply V in, get In out of it. V in will have two paths, Gm V in and R0. So what will be the Rin? 1 by Gm parallel with R0. So Rin would have been 1 by Gm parallel with R0. Right? Both will give the same result. I just interchange the scenario, nothing else. Source grounded, drain gets shorted. From where I am collecting? From drain. From here. There you go. Okay. Let's go to the next circuit. Let me know the Rx value. Rx or Rin, like they can give any name. They can call it R out as well. So here I am giving a random name Rx you need to tell. Should be able to tell. What you will do? This VGG is a DC bias. In place of VGG, I will write V in here. Okay. What I am saying? This is given in the examination that this V in is the small signal voltage. Small signal voltage. So what you are going to do with this small signal voltage? You will connect it to ground. So if I connect it to ground, then what will happen? What will be my circuit? This will be my circuit. And this R0 is connected in between, or you can say R0 is connected to ground as well, because this is connected to ground only. And what I need to find? I need to find Rx. In this manner they can say, or in this manner they can say that I need to find Rx in here. Okay. This Rx I need to find. So what I will do? I will apply some Vx and get Ix out of it. So my target is, my Rx is equals to Vx by Ix. Can I write down the current in R0? Yes. What will be the current? Vx by R0. Because this node is also Vx. Now this node is also Vx. So Ix is being divided into two parts. One is through R0 and another one is through this MOS. But what will be the current in MOS? What do you think? The current in MOS will be Gm into this potential minus this potential. What that would be? 0 only. So small signal current in the MOS is 0. Small signal current in the MOS is 0. So now the MOS can be replaced with open circuit. What you will see in the examination, if you feel like that, sir, in the circuit my VGS is gone. My gate to source potential is 0. My gate is also at 0, source is also at 0. It's not necessary that both will be like both are 0. You just need to see that both are at same potential. Let's just say this was at V1 potential. Let's just say this was at V1 potential and this was also at V1 potential only. So then also what will be the current? Gm V1 minus V1. Again the current would be 0. Both are grounded. Then what will be the current? Again will be 0. So if your gate to source potential or source to gate potential is 0, then there will be no current in the MOS. And if there is no current in the MOS, that means MOS can be replaced with open circuit. So how much resistance you see? Only R0. So what will be the answer of Rx? That is R0 only. Or what you can see? That sir, Ix is flowing, but the Ix will be flowing only into R0 only. So what is Vx? Vx is equals to Ix into R0. So what is your Rx now? That is equals to R0 only. But in the examination, what I will do, I will just see the circuit. I will say that sir, Vin is grounded, this is grounded, grounded, 0 current, Rx is directly R0. Believe me, when you revise all these notes, then you, by just looking at the circuit, you will be telling the answer. Here I am taking like 5 minutes, 6 minutes to solve one particular circuit. But in the examination, it will not take you time. That I can guarantee. Okay. Solve this question. Vx is the small signal voltage. Vx is small signal. And VDD is DC. This is given in the examination. Solve this question on your own. I need the answer. What will be the value of Rx? Vx will be grounded. What will happen? VDD is grounded. Vx is grounded. From here I need to calculate. So from here to ground, what I will see? R0 only. So what will be the resistance? This potential is gone, this potential is gone, and these two decide the potential. These two decide the current in MOS. So if I write down the current in downward direction, what that would be? Gm into 0 minus 0. So current in MOS is 0. So there is no current in the MOS. So from this node to ground, what do you see? Rx. What do you see? Rs is equals to R0 only. From this node to ground, Rx is equals to R0. There you go. Okay. Well and good. Let's go to the next one. R0 is infinity. You need to find V0 by V in. R0 is infinity given. Okay. R0 is infinity. This is given. You need to find V0 by V in. Try doing it. Use your brain. Whatever the brain you are having, use your complete brain. And let's see if you are able to answer that or not. V0 by V in, small signal voltage gain you need to find. So what will be the first step? R0 is infinity. That means it will not come into action. VDD will be gone. This will be your RD. Here this will be V in. This will be your Rs and this is your V0, right? Now the thing is, can I write down the current in MOS? Yes, I can write down, but my current will be Gm V in minus this potential minus this potential. And do I know this potential? No. So what I have to do? I have to assume any potential V here. If you don't know the potential, then you assume it. But my target is what I need. I need to find V0 by V in. So my target is I want to use all the terms in terms of V0 and V in only. What I mean to say is that I don't want to introduce another variable. I can introduce it. The current will be this. Then what I'm going to do, I'm going to write down the current here. What that would be, the same current will be flowing. Because if this current is Gm V in minus V in, the same current will be flowing here as well, here as well. In the complete circuit, there is same current. So this current will also be Gm V in minus V. Then I can write down V0 potential in terms of V in, V, Gm and RD. Then I will need to eradicate this V. How will I eradicate this V? V by Rs will be equals to minus V0 by RD. Say yes or no. V by Rs will be equals to minus V0 by RD. Are you getting this point? Because what is the current in upward direction? V0 by RD. What is the current in downward direction? V by Rs. So from here I will get the relation and in that manner I can solve. So this is one way of solving it. Other way could be just don't even introduce this V. Don't even introduce this V. So here all these terms should be gone. So I am not even introducing this V. So what I am doing? One thing I know, that what will be the current in upward direction? That would be V0 by RD. V0 by RD. Right? So this V0 by RD current will be flowing through the MOS as well, and the same current will be flowing through this RS resistance as well. So this will be the V0 by RD current. Right? So here what will be the potential? So current will be flowing from downward to upward. So what is the potential you are having? V0 by RD into Rs minus sign. So those who have studied this subject and those who have studied feedback topology, so no matter from wherever you have studied, your educator, your teacher would have always said that this is a voltage sampling circuit. Voltage sampling circuit. Now do you understand why it is voltage sampling? Because your output voltage is being sampled in minus V naught by Rd into Rs term, and that will be mixed with the input. How it will be mixed with the input? Because what is the current? If you are someone who did not study feedback topology and you are not able to understand what I am saying, then you can ignore this part. Our target is to find V naught by V in, but this I am telling only for the students who have studied it, because this is a very confusing example for a lot of students. They never understand that why there is voltage sampling and why there is voltage mixing. So why there is voltage sampling? Because V naught by Rd, the same current is flowing through Rs as well. So the same current is flowing through Rs as well. So how much is that voltage drop across Rs? That is V naught by Rd into Rs. That means what will be this voltage drop? That will be minus V naught by Rd into Rs. So now what will be the current in MOS in downward direction? The current in MOS will be Gm V in minus this potential. And what is this potential? This potential is this thing. That is equals to V naught by Rd into Rs. Although I want to discuss 10 more things, 10 will be a higher number, like I can discuss at least 3 to 4 more things about this particular circuit, but I cannot do it because this is not a comprehensive course. In comprehensive course we study a lot about this particular circuit, but here we are not going to study it. So are you able to understand now, those who have already studied it? So now what we have done, we have written down the current as well. So what is the current in MOS? That is Gm V in minus this potential, and this potential is equals to minus V naught by Rd into Rs. So this current I have written down. Now the same current will be flowing through this Rd as well, no? The same current in downward direction, the current will be flowing through this Rd as well. And how it will be flowing? From up to down. So this is how it will be giving the drop. So how I can write down my V naught? My V naught will be whatever the current that is flowing. Which current is flowing? This current is flowing. So V naught will be minus sign. Why minus sign? Because voltage drop will be negative here, right? This current I have written from up to down. So this is the current I am getting. So 0, and this is the negative sign. So negative sign is coming, minus Gm into Rd into V in plus V naught into Rs divided by Rd. Rs divided by Rd. Are you getting this point? So let me take it a bit upward. So what we are getting? V naught is equals to minus Gm Rd V in minus Gm Rs V naught. So what you are getting? V naught by V in minus Gm Rd upon 1 plus Gm Rs. This is the answer. Have we seen this particular factor? Yes, minus Gm Rd. Where we saw? Here, not here, sorry. Voltage gain we saw now. Minus Gm R naught parallel with R. Or in place of this R naught parallel with R, I could have written Rd as well. So the gain was minus Gm Rd. Now this is the same circuit only. This is the same circuit, but now this Rs is also connected. Now here what did I say? This is a negative feedback and it is a voltage sampling. And in voltage sampling, the gain will be reduced by A upon 1 plus A beta factor. So it is reduced by this particular factor. Right? This is just some other topic, like I am getting deviated from the original topic. So let's not do it. Here we are studying only MOS amplifier. We are not studying about feedback topology. But just I wanted to relate the things. If you are someone who has already studied this particular topic, so now you are able to relate. This is how you can get into the depth of analog electronics. But now we are not doing that. We are just writing down whatever that is required. So was it easy to find the gain? It was not that tough. Certainly it was not easy, but it was not that tough. Without even writing down any model or anything, we have written down the gain. Right? Let's go to the next one. Again, I need to write down the gain, but now R naught is also there. But the important point is these resistors are also there in terms of R naught only. So try writing it down. What you can do? What we will do? Simply first I need to tell the current in MOS. How much current is flowing in the MOS? So can I tell the current in MOS? Gm into V in minus something. I don't know this potential. But I want to tell this potential in terms of known voltage only. So what I can do? What I will do first thing, VDD will be gone. VDD will be gone. So what is the current that is flowing through 2R0? That would be V0 by 2R0. Say yes or no? That current is V0 by 2R0. And why I am doing so? Because this V0 by 2R0 current will be going into the MOS. Let's just say this is your V0 by 2R0 current. So this V0 by 2R0 current would be addition of these two current. And this current would be coming from R0. So R0 was there, that was divided into two parts, and then it became V0 by 2R0. From here the current started, this was the I current, then it went into two parts, then again added, and the final current we got. And that final current is V0 by 2R0. That means how much this current would have been there? This current would have been already V0 by 2R0 only. Say yes or no? Are you getting this point? So if that current is V0 by 2R0, that means downward current is also V0 by 2R0. So if this current is V0 by 2R0, that means what will be this drop? This drop will be V0 by 2R0 into R0. So what you are getting? Here what you will get? Minus V0 by 2. V0 by 2 R0 into R0. So here what will be the voltage drop? Minus V0 by 2. Right? And why I found that voltage drop? Because my target was to find the current in MOS. And why I wanted the current in MOS? Because at V0 I can apply nodal. At V0 I can apply nodal. What I can do? From V0 to ground, what is the current? V0 by 2 R0. From V0 to ground there is current V0 by 2 R0. Plus from V0 there is another branch, this branch. And in this branch how much current is flowing? V0 minus this potential divided by R0. So V0 minus this potential, that is minus V0 by 2. So here plus will come divided by R0. Plus now from V0 to ground, from V0 there is another branch. That means this current also I need to tell. What is that current? From V0 to this, there at V0 you are having three branches. One current is this one, another current is this one, and this is the another current. So three branches will have three different current. V0 by 2 R0, V0 plus V0 by 2 divided by R0, and here in the MOS as well there is one current. What is that current? GM V in plus V0 by 2, and that is equals to 0. Are you getting this point? Is that tough to understand? Like, believe me, a lot of students will be treating this question as very tough because they will be making needless model, and if you make the models then it will become very tough. But just if you have written down this equation, everything is there in terms of V0 and GM V in, everything. So can you get the value of V0 by V in from here? Very easily you can get the value. So this much easy it is. Just you need to look at the circuit and think about it. And if you are able to do that, then your job is done, right? So here what we will get? V0 by 2 R0. So yeah, V0 by 2 R0 into R0. This was minus V0 by 2. So this will be 3 V0 by 2 R0. So this is 3 by 2 plus 1 by 2. So this will be 1.5 into 0.5. So this will be 2. So 2 V0 by R we are getting. 2 V0 by R plus GM V0 by 2 is equals to minus GM V in, right? 2 V0 by R0. So V0 what we are getting? 2 by R0 plus GM by 2 is equals to minus GM V in. So what is V0 by V in? Minus GM upon 2 R0 is already there, that is 4 plus GM R0. So what we are getting? Minus 2 GM R0 upon GM R0 plus 4. This is the answer. In the examination they can give you the value of GM R0. Like in the examination they can say that if GM R0 is equals to 2, then what will be your V0 by V in? These kind of questions they can ask. So if GM R0 is equals to 2, then answer would be minus 4 divided by 6. Minus 4 divided by 6, that would be minus 2 by 3. So this will be the answer. Okay. Let me check the calculation because this was a bigger calculation. So I will check the calculation, I will take a break, and then we will move to the next one. So this is the next question. You need to find the V0 by V in. Try doing it on your own. I will take a break, I will check the calculation as well. I will check this calculation as well. You see the circuit, pause the video, try solving it, and then check the answer. And I will also take a break now. Okay. Yeah. So try doing it. Yeah. So the previous question was having all the calculation correct. Now let's start with this one. So V naught by V in I need to find. Okay. So how will I find that? Very easy actually, but R naught is infinity. Okay, R naught is also given infinity. Again, it is very easy. How? What is the current here? Can I write down the current? Yes, I can write down the current. What will be the current? Gm V in minus V naught. Right? Gm V in minus V naught. And the same current is flowing through RS. Gm V in minus V naught. So can I write down V naught in this manner? This is how I can write down V naught. How I can write down? V naught is equals to Gm into RS V in minus V naught. So what I am getting? V naught is equals to Gm RS V in minus Gm RS V naught. So what we are getting? V naught by V in is equals to Gm RS upon 1 plus Gm RS. If Gm RS is pretty large, then it will be nearly equals to 1, right? This gain is nearly equals to 1, but forget about this thing. This is the gain, GMRS upon 1 plus GMRS. But why did I take this example? This is a standard circuit. Okay. This is a very standard circuit. This is known as, VDD will be grounded, no? So this is known as common drain. So the voltage gain of common drain is nearly equals to 1. Why it is known as common drain? Because your input is applied at gate and you are collecting the output at source. No use of drain. That means drain is grounded. Although drain is not directly grounded, it is connected to RD and then grounded. But input at gate and output at source. At drain you are doing nothing. So this is known as common drain. What was this thing? Input at gate and output at drain. At source there is nothing. So this is common source. Right? Input at gate, output at drain. At source there is nothing. So this is known as common source. What was this? This was also a common source. Input, output, common source. And here Rx and all these things we are finding. So yeah. But one very interesting thing we will see. Okay, very interesting thing. This is also a very good method. You can tell the answer from this method as well. But now let's see a very interesting thing. Can I say that from V0 to V in I see 1 by Gm? Yes. Because from V0 there is only one branch. That is this branch. So I can certainly say that, sir, from V0 to V in I see 1 by Gm. From V0 to V in I see 1 by Gm. Say yes or no. And from V0 to ground, what do I see? RS. V0 to V in I see 1 by Gm. From V0 to ground I see RS. So this was my V in and this was my V0. V0 by V in I need to find. V0 by V in I need to find. Can I apply the potential division? Yes. What will be V0 by V in? RS upon RS plus 1 by Gm. So what is the answer? Gm RS upon Gm RS plus 1. So this will be my V0 by V in. Gm RS upon 1 plus Gm RS. Right? This is your V0, this is your V in. So from V0 to V in I see 1 by Gm, from V0 to ground I see RS. So V0 by V in is simply the potential division you need to do. So again a very good method. Right? Let's go to the next question. You need to find Rx from here. Try doing it. This is also a very good circuit, very standard circuit. Okay. So try finding Rx. What you will do? This current source, this will be gone. VDD will also be gone. Okay. So what will be your final circuit? So final circuit will be something like this. This is ground. This is R0. Rx I am saying. So you apply Vx and get Ix out of it. And from source to ground, what do you see? Rs. Okay. What is my target? Rx I need to find, that is Vx by Ix. Now this is the Ix current. Now Ix current will be divided into two parts. And then both combined, Ix current will be divided into two parts. And then both combined will be flowing through this Rs. What will be the value of this current? That I am asking. This will be Ix only. Are you able to understand this point? You should be able to understand this point because we have seen a lot of circuit like this. Ix is divided into two parts and then both combined will be again flowing through Rs. So if this is Ix, this will also be Ix. And why I am writing down so? because I need to name this potential, because I know that this potential is 0, but if I need to write down the current in the MOS, then I need this potential, and I don't want to introduce another variable. So in terms of Ix only, I can write down this term, that will be Ix into Rs. So what will be the current in MOS? What will be your Ix equals to? Ix will be equals to the current in the MOS going downward. What is that current? That current will be Gm into 0 minus Ix into Rs, because I am writing down the current downward. So from 0 to Ix Rs I am going, plus Vx minus Ix Rs upon R naught. Say yes or no? Ix is equals to Gm I naught minus Ix Rs plus what is the current in R naught? Vx minus Ix Rx divided by R naught. The current in R naught is Vx minus Ix Rs divided by R naught. So what you are getting? Okay. So Ix is equals to, so here I am saying Ix plus Gm Rs Ix plus Ix Rs upon R naught is equals to Vx upon R naught, right? So what you are getting from here? Vx by Ix, Vx by Ix, Vx by Ix I need to get. So R naught will be cancelled. So what will be the answer that I am writing down here? So that will be R naught plus Rs plus Gm R naught Rs. This will be the answer. So when I was looking from here to upper side, my answer was R naught plus Rd upon 1 plus Gm R naught. If you remember, R naught plus R, that was R naught plus R upon 1 plus Gm R naught. When I was looking from source, gate was grounded. Gate was grounded, I was looking from source. Answer was R naught plus R upon 1 plus Gm R naught. If I am looking from the drain, so the answer is R naught plus Rs plus Gm R naught Rs. What is the answer? This is the way you will remember. R naught plus Rs plus Gm R naught Rs. Are you getting this point or not? You are getting two kind of resistance. I have made the circuit here. Okay, forget about this circuit once. Let's see these two results. Have we seen this circuit before? Yes. Looking from the source. Looking from the source, what was the answer? R naught plus Rd. R naught plus Rd plus Gm R naught plus 1. Or you can say 1 plus Gm R naught. R naught plus Rd. R naught plus Rd upon 1 plus Gm R naught. This configuration will provide Gm R naught. In that manner you can remember. Looking from the source. This is the resistance. Looking from the source. And looking from the drain. What is the resistance? Looking from the drain. So R naught plus Rs. R naught plus Rs plus Gm R naught Rs. People always get confused that, sir, we will remember these two formula, R naught plus Rd upon 1 plus Gm R naught, R naught plus Rs plus Gm R naught Rs. Sir, we will remember this formula, but sir, which one will be for drain, which one will be for source? That we forget. So you can make your own trick. How do I usually, how you can remember? So let me tell you a trick. So this is from looking from drain, and this is looking from source. So the resistance from source is coming in two steps, no? Like there is numerator as well, there is denominator as well. Numerator and denominator both are there. But here there is only one line. There is only numerator, there is no denominator. Denominator is 1. So if you are looking from drain, drain means you are drained. Like my battery is drained, the mobile battery is drained. That means battery is at 0. So if battery is at 0, then battery is not having any energy. You are not having any energy if you are drained. You are looking from drain, that means you are drained. And if you are drained, that means you are not having any energy. And if you are not having any energy, then will you write 2 steps or only 1 step? I will write only 1 step. So looking from the drain, I write only 1 step. And looking from the source, you are the source. You are the source of motivation. So your energy is at very high. So looking from the source, what you will write down? 1 step as well, another step as well. That means you will write down 2 steps. This is just a very crude way of remembering the formula. Okay, very crude way of remembering the formula. But you can remember if you want to remember in this manner. Right? R naught plus Rd upon 1 plus Gm R naught. R naught plus RS plus GM R naught plus RS. R naught plus RS plus GM R naught RS. Okay, these two formulas should be there in your mind. Okay, let me take a break because again I need to take some break because of the headache problem that I have. So I will pause a bit and then I will come back. Yeah, so let's solve this question. Did you try solving this one? This is a very good question. Answer will be the gain will be 0. Why is that so? Let's check that out. So what we need to do first, I will make the model. I will make the small signal model. So that model will be looking something like this. Right? This will be your V in, and here this is your R naught. This is your V naught, and from V naught to ground there is RS. This current source will be gone, VDD will be gone, right? Now what is the current in this MOS? That current is GM V in minus V naught. The current is GM V in minus V naught, right? Now this current will be flowing through this branch here, and that will be flowing through R naught as well. Are you getting this point? Let me make this circuit here. Let me make this circuit here again. This is my R naught. A very important point I am going to explain. And this is my RS. And here this is my V in. And this was my V naught. This was the circuit, right? From upper side current source is gone. So what is the current here? Let's just say the current is I. That is GM V in minus V naught. The current is I. The same current has to flow here as well because this current has no other path. If this current is I, so this current has to flow here as well. Now this current has no other path. This current has to flow here as well. So now from here to here, I current is flowing, right? Now this I current, this current has to flow here as well. Why is that so? Because this I current does not have any path. Now you will not say that sir current will be going here. No, I not V naught will not drive any current. The current will not be going here. This is not a potential. This is not any potential. This is just a node. So this node will not take any current. So this I current has to flow here as well. So now at this node, what do you see? At this particular node, what do you see? From upper side, I current is coming, and here I current is going. So what do you think? What is the current going in RS? At this particular node, what do you see? From upper side, I current is coming, and to this side, I current is going. That means this I current is flowing in the complete loop. Are you getting this point or not? This I current is flowing in the complete loop. This is just network analysis, basics of network analysis it is. If you have studied network analysis from PrepFusion, then these kind of points I explain with a good amount of patience there. Because these are very important. Students ignore these kind of points. That's why they get the answer wrong in the examination. So I current is flowing in the loop only. And how did I get to know? I get to know I current is flowing in the loop because if this is I, this is I, this is I, this will also be I. So from here, there will be no current going into this branch. Although this current I has two paths. One path is this one, another path is this one. But when I analyze the circuit, I got to know that this current is also I only. Right? So this I current had two paths, one to go here, one to go here. But in this path only it is completely going. And if it is completely going in this path, that means RS will drive 0 ampere current. So this RS is driving 0 ampere current. And if it is driving 0 ampere current, then what is your V naught? 0 into RS. So what is my V naught? 0 only. So forget about anything. What is your V in? V in will be a finite voltage that you will apply. That will be 0 by anything. That will be equals to 0. That's the answer. Okay. A very good question it was. Previously we skipped one problem here. So what we were seeing these resistances. We got to know that looking from drain only one step R naught plus RS plus GM R naught. Looking from the source R naught plus RD upon 1 plus GM R naught. Now this question. Looking from the drain, what is the answer? Forget about the analysis. What will be your Rx? Looking from the drain, what is the answer? Looking from the drain, if gate is grounded and source is connected to some other resistance, the answer is R0 plus RS plus GM R0 RS. Now what I am saying, R0 is infinity. It is saying that R0 is infinity. So if I put infinity plus GM R0 RS, that is also infinity. So what is the value of Rx? That is infinity only. Okay, answer is infinity. But let's solve it without any formula. So if I need to solve it without any formula, so what I will do? I will apply a Vx here and get Ix out of it. Right? So what will be my Rx? Vx by Ix. So this Ix will be flowing in this MOS only because R0 is 0. So Ix will be completely flowing in the MOS. So this current will also be Ix. Why I am doing so? Because I need the current in MOS. So from upper side Ix is coming, the same current is flowing in this MOS as well. So this current will also be Ix. So what will be this potential? This potential will be Ix into Rs because current is flowing from up to down. So plus to minus. So this potential will be Ix into Rs. Now what will be the current in MOS? The current in MOS. The current in MOS will be minus Gm Ix into Rs. Did you understand this point? Or you can write down the current in upward direction as well. You can write down the current in upward direction as well. What will be the current? From Ix Rs to you are going towards 0. So what will be the current? Gm into Ix into Rs. So from here what you are getting to know that Gm into Ix into Rs is coming out to be equals to minus Ix. Say yes or no? Gm into Ix into Rs is coming out to be minus Ix. So from here what you can see, Gm Rs plus 1 is equals into Ix is equals to 0. So from here what you are getting to know that Ix has to be 0. This GMRS is depending upon you. You can make it like, if you solve this circuit, then there are two possibilities, no? That either Ix can go to 0 or GMRS can go to -1. But RS is something, any random RS I am putting, and any like GM is depending on the biasing parameter, but it's not necessary that always it will be equals to -1. It can be equals to anything. So that means certainly Ix has to be 0. So if Ix is 0, so what you will get? Vx by 0, that is equals to infinity. So in the examination, if I am the educator, if I am the paper setter, although I will never be, so I will ask this circuit because I know that those who have studied it, they already remember this formula. They already, like a lot of students already remember this formula, R0 plus Rs plus Gm R0 Rs, but they don't remember this one, right? They will see the circuit and they will try solving it by any model or anything like that, and then they will be getting puzzled. So in these kind of scenario, if your equation is becoming strange, then no need to worry. Strange equation can also come. Okay. So have the patience, you got to know that Ix is equals to 0 and then Rx is equals to infinity. Or how you could have solved it. I know that looking from the drain, if my gate is shorted and source is connected to Rs resistance, then my answer is R0 plus Rs. I am looking from drain. That means I am drained. My battery is drained. That means I will write down only one step, R0 plus Rs into Gm R0 Rs. And if R0 is infinity, if R0 is equals to infinity, so infinity plus Rs plus infinity. So what will be your Rx? Rx will be infinity only. Okay, so this will be the answer. Well and good. This also we have solved. Let's go to this one. What you need to find, considering R0 is not equals to infinity, you let me know what will be your Rin. And then considering R0 equals to infinity, you let me know what will be your gain. Okay, these two questions are there. So Vin is here, V0 is here, you need to find Rin. So first let's find Rin. Do I have the page? Because it will take 2 pages. So first let's find Rin. So how will I find Rin? So for Rin, what did I tell you? All kind of biasing will be gone. Whether it is small signal bias or, sorry, by small signal, we cannot call it bias. So whether it is a small signal or it is a large signal, everything will be gone. So VDD will be shorted, Vx will be shorted. Let's make it on the next page only. Okay, yeah, let's do it on the next page. So there VDD will be shorted, Vx will also be shorted. So this was the circuit. This is also gone. This is also gone. This is gone. This is also gone. Okay. Then downward I see V in. And then at the ground I see Rs, and this is my V naught. So this is the small signal circuit at least. But if I am finding Rin, that means I will nullify V in as well. There are two questions. In the first question, you need to find Rin. So if I am finding Rin, then this V in will also be nullified. V in will also be nullified. And here there is R naught. Upper side we are calling M2, downward I am calling M1. So this will be your R naught 1, and upper side you are having R naught 2. What did I tell you? From where you need to find Rin? From where I need to find Rin? Okay, let's change this circuit once. Okay, I am changing the question. I am asking you the Rin from here now. From here, where I am asking? I am asking the Rin from V node side. From V node side, I am asking the Rin. From V node side, I am asking the Rin. Now, what do I know? That from V node to ground, I see Rs. From V node to ground, I see Rs. And from V node to ground, I see this another circuit. Say yes or no? From, or what you can say, sir, from V node to ground, I see Rs. From V node to ground, I see 1 by GM as well. But from V node only, I see another circuit. If both were connected, then I could have said that from V node to gate and from V node to drain, I see 1 by GM parallel with R node. But now both are not connected. Now first my target should be, if I am finding the Rin from here, I should start from the upper side. So I need to solve this circuit. What do you think how this circuit can be solved? And from where I will write down the resistance from downward side? Because I will start solving from the upper side. Like first I will get the resistance of this part, then this part, then this part, looking from downward. So looking from downward, how I can replace this circuit? Think about it and let me know. What will be the current in MOS? Source is 0, gate is 0. Current in MOS will be GM 0 minus 0. VSG is gone. Source potential and gate potential both are 0. That means current in the MOS is 0. So this MOS can be replaced with open circuit. These are considered as a very tough problem in the examination. Believe me guys, these are considered very tough problem. But if you know the concept, whatever that I have taught you in the first initial 20 minutes, then you will be able to solve all the problems. VSG is gone. Then how you will replace R0? Sorry, how you will replace the complete configuration? Only R0 is left, no? From this particular node to ground, only R0 is left. Say yes or no. Now, coming to this part. This is my, this was R0 2 actually. This was R0 2. This is R0 1. And this is my RS. So this is how I have replaced the circuit. Now from here, I need to tell the resistance. So now I need to replace this circuit because I know that from V0 to ground, I see RS. From V0 to ground, I see RS. From V0 to ground, I see 1 by GM as well, but gate and drain are not shorted to each other. That means from source side, I am looking. From source side, I need to write down the resistance. Drain and gate are not shorted to each other and drain is connected to another resistance. Have we seen this kind of circuit before? Yes, not here, sorry. From source, I need to tell the resistance. Gate is grounded, drain is connected to RD and then there is a R0. And drain and gate both are not shorted to each other. Here we have seen, previously also we have seen, and I wrote down the conclusion as well. Three kind of circuit we see. From source we are seeing the resistance, gate is grounded, drain is connected to R resistance and it is connected to R0. And in between there is R0. If there was no R0, then answer would have been 1 by GM. If there is R0, then answer is different. And if both are shorted, then answer would have been different. Say yes or no. We have seen it, right? So same circuit, same kind of circuit we are seeing here as well. Looking from upwards, from source we are seeing R0 2 is there, R0 1 G, and this gate is shorted as well. So looking from upward, how much resistance you will see? I am looking from the source. I am the source of motivation. That means I will write down two steps. How I will write down? R0 1 plus R0 2 divided by 1 plus GM R0 1. GM 1 R0 1. R0 2 plus R0 1 divided by 1 plus GM 1 R0 1. So upper side you see this much resistance. Now your circuit is solved. How your circuit is solved? That from V0 to ground, you see R0 1 plus R0 2 divided by 1 plus GM 1 R0 1. And from V0 to ground, you see RS as well. So looking from V0, how much total resistance you see? RX or Rin, whatever it is. So they are in parallel or they are in series. What you will say? From V0 I need to check, no? From where I need to check? From V0 I need to check. So what I will say? From V0 to ground. From V0 to ground I get any R1 resistance. And from V0 to ground I get another R2 resistance. So answer will be R1 parallel with R2. So from V0 to ground I get this resistance and from V0 to ground I get RS resistance as well. So what will be the answer? what will be the value of Rin? So value of Rin will be from V0 to ground, that would be R01 plus R02 divided by 1 plus GM1 RO1, that is in parallel with RS. That will be your Rin or Rx, whatever we can call it. We are calling it Rin, although this is not Rin because this is the applied input, no. So I should have called it Rx. Okay. So this is not Rin, this is your Rx. So what is my Rx? Are you getting this point? How I am doing these kind of questions. So no matter how big the circuit will look like, you can any day solve any problem. Just have confidence on yourself. Just keep on writing on the steps that you know. If you are able to do this thing, at least you will be able to match the option. That I can tell you. At least in the examination, if options are given, then at least you will be able to match the options. Believe me, guys. If you have just gone through this video, VGS is gone, R0, R02 is replaced, R02 is replaced, then looking from downward, I have seen this circuit. What is this circuit? R0 plus R0 plus R02 divided by 1 plus GM R01, and RS will also come in parallel. That's the answer. Okay. Let's see the circuit now from where these capacitors came into action. So I just deliberately introduced these capacitors. The point is, when you do the small signal analysis, the capacitor will be shorted. Capacitor will be short circuited. When you do the small signal analysis, capacitor will be short circuited and VDD will already be gone. And what I do here is that I apply, okay, let it be grounded only. Let it be grounded only. Okay. So VDD will be gone. What will happen to capacitors? Capacitors will be open circuited. These are known as coupling capacitor. Why do we use it? All these things we study in comprehensive course. So you don't need to study, you don't need to think anything about it. Just you need to know that capacitors will be shorted. So capacitor is shorted. This is RD. This is our RS. And this is our V. So what kind of circuit it is? What do you think? You will call it common gate, common source or common drain. Common gate, common source or common drain. What is your answer? Input is applied at source and output we are collecting at drain. Gate is of no use here. So common gate circuit it is. Okay. What we need to find? V0 by V in we need to find. And any other condition is given. Shall we consider R0 here? Yeah. Okay. We can consider R0. It will not be that tough. So we can consider R0 as well. If we don't consider R0, then it will be very easy. But let's consider R0 as well. Let's make it on the tougher side. Okay. So what we need to find? V0 by V in we need to find. Small signal circuit I have already made. Try doing it. If this is my V in, what will be the current in MOS? Why I need the current in MOS? Because I will apply nodal at V0. I will apply nodal at V0. What will be the nodal at V0? V0 by RD plus V0 by V in minus R0. Sorry, V0 minus V in divided by R0 plus the current in MOS. What is the current in MOS? V0 by RD plus this current, and you need this current now. Downward current, no? From V0 to downward side and upward side. So V0 minus V in by R0, V0 by RD plus or minus plus what will be the current? The current will be minus GMV in. This is your MOS, right? This is shorted and this is your V in. So what will be the current in upward direction? GMV in. So in the downward direction, the current will be minus GMV in. Or you can say, if I need to write down the current in downward direction, so GM into 0 minus V in, that would be minus GMV in. So current will be minus GMV in. So I am applying the nodal analysis. So plus minus GMV in is equals to 0. So this is what we are getting. So V0 upon RD plus V0 by R0 is equals to GM R0. GM V in goes here, 1 by R0 goes here. So let's do something. GM plus 1 by R0 into V in. So yeah. So what I can do? Can I write down in this manner? V0 divided by RD parallel with R0. Did you understand this step? V0 divided by RD parallel with R0. You should be able to understand. Try relating it. If you are not able to understand directly, then spend your time, because this I have already taught. 1 by r is equals to 1 by r1 plus 1 by r2. Same thing is happening here. Try understanding it. Try understanding it on your own. Okay? Or shall I explain it? Basically, what is this? V naught into 1 by rd plus 1 by r naught. And what this is what this can be equivalent to? 1 by r equivalent. So what is your r equivalent? Rd parallel with r naught only. So V naught by rd parallel with r naught. Right? That is equals to, although this is of no use actually, gm r naught upon gm r naught plus 1 into V in. So what is the V naught by V in we are getting? Gm r naught plus 1 upon r naught into rd parallel with r naught. Anyway, I need to solve it. Rd plus r naught. So r naught is getting cancelled. So what we are getting? Rd upon Rd plus r naught into 1 plus gm r naught. Okay. This is your V naught by V in. Say yes or no. What if the r naught was infinity? Then what will be the answer? GMRD only. Right? If r naught was infinity, then what would have been the answer? GMRD or another answer will be possible? No, GMRD only. V naught by RD if I say, and V in by RS if I. Look, let's take R naught equals to infinity. Okay. What we are saying, let me add a page, and what I am saying, the same circuit R naught is equals to infinity. The same circuit R naught is equals to infinity. Small signal model, I know. This will be my V naught. This is my V in. Okay. So what will be the current in upward direction? That would be GMV. This VDD will be gone, that will be shorted. Right. So what is the what this GMV in will be flowing here as well, because R naught is infinity. So V naught is equals to, since the current is flowing in the upward direction, so this will be positive, this will be negative. So V naught is equals to GMRD into V in. So what is the gain? V naught by V in is equals to GMRD. Okay. This is the gain. But just one thing click to me. What is that? What is the current in downward direction? V in by RS, right? And what is the current in upward direction? V naught by RD. Am I doing anything wrong here? V in by RS is the current in downward direction. V naught by RD is the current in upward direction. Say yes or no. Is there any issue about that? No. And both current will be equal. What say? What is the issue with this one then? Why both current will be equal? Because if this is the current, then this will be divided into two parts. This will be added back, and then if both are added back, then the same current will be flowing here. Are you getting this point? In the downward direction, V in by RS current is there, and in the upward direction, V naught by RD current is there. Both has to be equal. So another answer we are getting, no? V naught by V in. So that V naught by V in is depending on RS and RD. Are you getting this point? What I am saying? What I am saying is that whatever the current, if I take this circuit only, R naught is finite. What I am saying, R naught is finite. If I say here there is I current, the same current will be flowing here as well, no? In RS as well. Say yes or no? So V naught by RD will be equals to minus V in by RS. Even if R naught is not equals to infinity, then also it is true, no? V naught by RD is equals to minus V in by RS. So what is the other value of the gain? Minus RD by RS. But am I doing anything wrong here? Minus RD by RS, because this is the first time this is occurring to me. I never thought of it. Okay. Just when I am teaching it, it came to my mind. Although there is a question in GATE examination based on this concept only. So this analysis is not wrong. There is nothing wrong with the small signal analysis, but if I see as an engineer, so this gain is independent of anything, like it is not even depending on any circuit parameter, it is not even depending on GM or not, it is not depending on anything, it is just depending on two resistance that user is connecting, RD and RS, or it is coming from any other stage. So how this common gate circuit is helpful then? It is independent of GM value. Okay, I will think about it, but for this video, like even for your examination, it is fine that you know how to write down the gain. So this is the one way of writing down the gain, but another answer is possible, that is minus RD by RS. Am I doing any mistake in this analysis? I don't think I am doing any mistake. If I am not doing any mistake, then certainly even if the R naught is finite, still this answer is possible, minus RD by RS. Even if it is finite or infinite, still this answer will be minus RD by RS. So this is a common gate structure and this is the voltage gain of a common gate. So common voltage gain of common gate is independent of GM. Common gate voltage gain of common gate is independent of any circuit parameters. Is that statement correct? Looking at the expression, this statement is correct, but usually we don't see this statement, right? Usually we don't get to see this statement. It is not even written down in any textbook as well. I just saw it and I got to know. I will think more about it. Okay, I will think more about it. And another interesting thing, what is that? Usually here there is no phase shift, right? Basically V0 and Vin both are in same phase. But if you go by this expression, then V0 by Vin are having different phases. I am certainly doing something wrong. I don't know, but I am certainly doing something wrong. If you go by this expression, what you can say? That V0 and Vin both are having a phase difference, no? Like both are having a phase difference of 180 degree. Because there is minus sign, basically V0 is equals to minus RD by RS into Vin. So V0 and Vin both are having a phase difference of 180 degree. Right? But usually we say that there is no phase difference. In common gate amplifier, there is no phase difference, but here I am getting it. Am I missing anything? Okay, that's a very good point that came to me. So I will ask someone, like someone who is working in this field for a very long time. So I will ask some other people. Okay, very good point that came to my mind. Okay, I will post it on LinkedIn, I guess. Then only I will get some answer. Okay, yeah, fine. So it just occurred to me. Otherwise, always when we study, we write down this gain and it is fine for us. But just when I was thinking that I current is flowing here, I current would be flowing here as well, then it just came to my mind that why we cannot write down the gain in this manner. What is the issue behind that? So I will put this query on LinkedIn, and I guess I am doing some mistake. I am not sure what mistake I am doing, but that will be taken care. Okay, yeah, no issue. Let's move to the next one. Now this question, it may feel like that it is a very big circuit, how we will write down the gain. But what did I tell you? Capacitors will be shorted and supply will be gone. VDD will be gone, capacitors will be shorted. So capacitor is shorted. So let's see how I will make the circuit. So VDD is gone. This VDD is gone. This is your RD. This is your V0. Now this RS is there. This RS is there. It is connected to ground, but the capacitor is shorted. So this complete RS is also shorted, no? RS is connected to ground, but capacitor is also shorted. So complete RS is also shorted. So can I ignore this RS? So RS is not open circuited here. RS is shorted because this capacitor was shorted, right? So this will be shorted. Now this thing is running into my mind as of now, that what really happened here. Two R by 3 resistance. This capacitor is also shorted, no? This capacitor will also be shorted. Now from this node to ground there is a resistance R. From this particular node to ground there is a resistance R. And from this particular node to ground there is a resistance 2R as well. From this node to ground there is resistance R. From this node to ground there is resistance 2R as well. So from this node to ground R is there, 2R is there. So can I say both will come into parallel? So 2R and R will come into parallel. Say yes or no. I can remove this thing and 2R and R will come in parallel. Because from here to ground there was R, from here to ground there is R. So 2R and R will come into parallel. So what will be the answer? 2R by 3. Parallel combination of 2R into R divided by 2R plus R. 2R by 3. Right? And now this is my Vs. This is my Vs. What I need, and R0 is also finite. So from V0 to ground as well I will see R0. From V0 to source I will see the R0. From V0, from here to here I will see R0. From here to here I will see R0. Right? This will be my R0. But since this node is connected to ground, so can I say directly it is connected to ground only? Right? So what I am saying here, this is my Vs. I need the potential here. If I need to write down the current in MOS, that means I need the potential here. So 2R parallel with R, 2R by 3. This is also 2R by 3. Basically, equivalent circuit is 2R by 3. This is also 2R by 3. Then this is the MOS. This node is connected to ground. This is your V node. So from V node to ground you see RD. From V node to ground you see R node as well. So from V node to ground you see RD. From V node to ground you see R node as well. And this is your Vs. This is 2R by 3. And this is also 2R by 3. So how much potential we are getting here? This will drive 0 ampere current. So can I apply potential division? Yes. 2R by 3 resistance, 2R by 3 resistance. This is driving 0 ampere current. So can I apply the potential division? Yes, I can apply. Basically, if this is my R resistance, this is my R resistance. And here I apply V in, V1. So what will be the potential here? V1 by 2. Same thing we are doing here. 2R by 3, 2R by 3. So what will be the potential here? Vs by 2. The potential here will be Vs by 2. So what will be the current in this MOS? The current in this MOS will be Gm Vs by 2. Or you can say, sir, this is simply common source amplifier and I remember the resistance Gm into Rd. Basically, whatever the resistance that V0 will see, Rd parallel with R0 and then multiply with, forget about it, don't remember anything. Okay, forget about this particular expression. Even if you have forget it, then also you will be able to solve. So if this is Vs by 2, so what will be the current in this MOS? Gm Vs by 2. Now this Gm Vs by 2 has only one path to follow. What I am saying, this current is Gm Vs by 2. This current is Gm Vs by 2. So that will flow from here and the same current will be flowing through the Rd as well. This current has only one path. So in Rd parallel with R0, Gm Vs by 2 current is flowing. So what will be your V0? In which direction the current is flowing? The current is flowing like this. So this will be plus, this will be minus. So V0 is equals to Gm Vs by 2 current is flowing. Gm Vs by 2 current is flowing. But the potential is negative into Rd parallel with R0. So what will be your V0 by Vs? That is equals to minus Gm Rd parallel with R0 divided by 2. So that is the final gain. Okay. It was actually very easy in the examination. You will not even have to draw the circuit. What you will see, sir, 2R R will come in parallel. This will be 2R by 3. This will be Vs by 2. This is also grounded. This is also grounded. So Gm Vs by 2, R0 parallel with Rd is there. R0 parallel with Rd is there. So Gm Vs by 2, R0 parallel with Rd. So Gm by 2, Rd parallel with R0. So this will be the gain. Very easily you will be able to write down. Till this step you will be reaching very easily. Or one thing I am going to tell, what I am going to tell is that you can remember this final expression. Which final expression you can remember? This expression at least you can remember. That if this is your MOS, here you are applying V in, and from V0 to ground, whatever the resistance you see, this is your R resistance. From V0 to ground, whatever the resistance you see, from here V0 by V in is equals to minus GMR. That's it. And it is very easy to drive. This current is GM in. The same current is flowing through this resistance R as well. This has to flow in this manner. So what will be your V0? Minus GMR into V in. From here we are getting this expression. So you at least remember this one. This is known as voltage gain of common source amplifier. That is minus GM into R. Okay. Try solving this question. You need to tell R in value. What you need to tell? You need to tell the value of R in. Next, what we are doing? Okay, then this question we are solving and then we are moving to PYQs. Okay, So solve for the value of R in. माइक वगैरह लगाया ना. Here what we are using, PMOSes we are using. Usually what we use NMOS. So even if the PMOS is coming, you should not be getting confused, right? So VX1 will be shorted, VDD will be shorted. Look, directly let me know now. VX1 is shorted, VDD is shorted. From here what we are seeing, there is already R0 is there, right? This is gone, VX1 is gone, VDD is gone. VSG is gone. Source potential is 0, gate potential is 0. That means MOS can be replaced with open circuit now. There will be no current in the MOS because the current in the MOS will be 0. GM 0 minus 0. So current will be 0. So from here to ground, how much resistance do you see? R0. From this particular node to ground, you see R0 resistance. Then there is a source. Vx is grounded. Let's just call it R02. Okay, let's call it R02. So this will be my R01. And from here I need to tell Rin. One thing what you can do, you can do the same thing. I apply V in, get In out of it, because this is not any standard circuit. You don't know, you don't remember the result, right? You apply V in, get In out of it, you can write down the value of Rin now. Okay, what you can do, this will be In, then the same In will be flowing through this In as well. Then what you will get to know, this potential. If you know this potential, then at V in you can apply nodal. Basically, In will be equals to the current in this MOS. Current in this MOS will be coming because you will know this potential. What will be this potential? This potential will be equals to In into R02. So current in the MOS will be from this particular potential. You can write down the current in downward direction, or if you need the current in upward direction, that also you can write down. And you can write down the current in R0 as well, because you know this potential, as well. So current in R0 also you can write, and that will be equated to In. From there you will get the answer. Okay, but have we done these kind of steps anywhere? Like in the examination, let's just say it did not click anything to you, you will do this step only. In the examination, if nothing is clicking to you, you will start doing this step. Then you will remember that we have done these kind of steps somewhere. Where we have done? Can I make the circuit? Can I make the same circuit using NMOS as well? This was PMOS. Can I make the same circuit using NMOS? Yes, I can make the same circuit using NMOS. What I will do, I need to make NMOS. Okay, I am making NMOS. Gate is grounded, gate is grounded. Between these two, R0 is connected, R0 is connected. From where I am looking? From drain I am looking. That means from drain I am looking. Source is connected to R02. Source is connected to R02, and that is connected to ground. Source is connected to R02, that is connected to ground. What kind of circuit is that? Do you remember the result? Yes. What is your Rin? From drain I am looking, gate is shorted. From drain I am looking, gate is shorted. Source is connected to R02. From drain I am looking, that means my battery is drained now. So what will be my Rin? From drain I am looking, that means my battery is drained. Battery is drained, that means only one step I will write down. R01 plus R02 plus GM1 R01. GM1 R01 R02. This is the answer. Have we seen this circuit anywhere or not? So if your circuit is reduced to only one circuit, if your final circuit is reduced to only one circuit, and that is PMOS, so what you can do, you can make the same equivalent circuit of NMOS, and then you will be able to understand that what is happening here. If you are not able to solve with respect to PMOS, because you will not be having enough practice with PMOS, right? Because you are just watching this video, and that will be the final video you are going to watch on MOS amplifier. So you will not have enough practice. And if you are not having enough practice, and then you get puzzled that what should be the answer, then what you can do, you can make the NMOS circuit, and from there you will get the answer. Are you getting this point? Are you getting this point? Where we have seen this circuit? Here we have seen this circuit. These two answers we have seen. Looking from the drain, looking from the source. What all are the resistance? Okay. Now usually what happens is that, usually in the examination as well you can get this option. R01, R02 and this GM R01, R02. So this quantity is very larger than R01 and R02. What I am saying, GM1, R01, R02 is very larger than R01 and R02. So sometimes Rin approximately can be replaced with GM1, R01 and R02. Okay, this could be the approximated answer. approximately, but you should remember the exact answer as well. Okay, you should remember the exact answer as well. R01 plus R02 plus GM1 R01 R02. Let's solve this question. What we need to find? R0. From V0 I need to find. So what I will get started with? This thing, this thing, this thing, this thing I need to solve. So from where I need to start? From here I need to start. So first I need to get equivalent of this one, then I need to get equivalent of this one as well. Right? So from here I am looking. So I need to solve downward as well now, upward as well now. So first let's solve the upper circuit. What will happen? This Vx1 will be shorted, VDD will be shorted. This is shorted, this is shorted. So VSG is gone. Source, gate potential, both are gone. 0 minus 0. That means there will be no current in the MOS, but there is R0 connected. R0 4 is there, right? R0 4 is connected there. So what will happen now? The upper part can be replaced with R0 4. So in my circuit, the upper part, this part can be replaced with R0 4, and this is connected to ground. Okay. Here what is there? R0 3 is there. I am solving only the upper part. Only upper part. Can you let me know the answer of this thing? What will be the resistance here? Same circuit. Same circuit. If you are not able to click, then what you will do? Grounded, R0 4, R0 3. From where I am looking? From drain I am looking. What is the answer? From here you will be able to understand. Okay, this is a standard circuit. I remember the result. From drain I am looking. That means my battery is drained. So this much circuitry can be replaced with R0 3 plus R0 4 plus GM3 R0 3, GM3 R0 3 R0 4. Say yes or no. GM3 R0 3 into R0 4. So upper circuitry can be replaced with this much of a final answer. Okay. Now let's see the downward circuitry. What I am saying, the downward circuitry. Because from V0 to ground I need to see. From V0 to ground I see this much circuit. From V0 to ground I see this much circuit. So let's see how the lower circuitry can be replaced with. So Vin is the small signal bias, small signal applied input voltage. So this will also be shorted. And from here to ground, or you can see from drain to source, what do I see? R01, which is connected to ground only. Here, what will be the current in MOS? Zero current. VGS will be 0. Gate to source potential will be 0. Or you can say GM 0 minus 0. Current will be 0 only. So this much circuitry can be replaced only with R01. So what do you see downward? This much circuitry can only be replaced with R01. And this Vx3 is shorted. Okay. And in M2, what do you see here? You see R0 to here. And here I see another resistance. Can you let me know what will be the value of this one? From V0 node I am seeing. Can you let me know what will be the value of this one? From drain I am looking, gate is grounded, from source there is a resistance. Very standard circuit. R02 plus R01 plus GM2 R02 R01. So what did you understand here? From V0 to ground on the upper side, from V0 to ground on the upper side I see one resistance. Let's just call this resistance as R1, this resistance as R2. So from V0 to ground, I see R1. From V0 to ground I see R2 as well. V0 to ground there is R1, V0 to ground there is R2. What will be your R out? R out will be equals to R1 parallel with R2. R1 parallel with R2. What is the value of R1? This is the value of R2. This is the value of R1. 99% of the gate aspirant will fail here. They will not be able to answer this question. They will say this is very tough. Is it tough? If you know the concept, if you have enough problem solving skills, these are not tough. This is a standard circuit as well. This is known as cascode amplifier with cascode current source in load. Usually when I teach this particular topic in comprehensive course, so I start right from the beginning that why we make this kind of amplifier. Here all the configuration that we have seen, no, like all these configuration, they have a reason that why we make this kind of circuit, why we use this current source, how we will use this current source, how we will make this current source. What is the reason behind that? All these things have been explained in the comprehensive course, but that we cannot do here because your examination is there after 12 days. So I need to teach in a very concise manner. So this is something new that I am trying, that I will try to deliver the complete concept within 2 to 3 hours, and I will see whether students are able to understand and students are able to solve the problems or not. So now we will see the gate problems, but not all the gate problems. Okay, only good gate problems we are going to see. Rest simple gate problems you can solve on your own. Only good gate problems I have picked, those problems only we are going to see now. So I guess on most amplifiers you will be able to solve decent problem. Like if two problems are coming, then at least one question you will be able to solve. So read this question, and in the examination, if you read it, what you need to see from there. Consider the circuit shown with an ideal long channel NMOS enhancement mode. Substrate is connected to the source. So you don't know what they are talking about here. Substrate is connected to source. So you can ignore this line. The transistor is appropriately biased in saturation region with VGG and VDD. That also you don't know. But you got to know that it is biased. That means biasing we have done. Appropriately biasing we have done. Such that it acts as a linear amplifier. Vin is the small signal AC input. This is a small signal AC input that they have given. VB is VA and VB are represented as small signal voltage at the nodes A and B. Find the value of VA by VB. This is what they are saying. VA by VB you need to find. Vin is a small signal voltage, but that is of no use now. Are you getting this point? Just look at this circuit, what you will think. That even if there is R0, they did not talk about R0 at all. Let's just say even if there is R0, even if there is R0 present, what will happen? Whatever the small signal current is there, let's just say the small signal current is I. The same current I will be flowing here as well. Right? This node is your VA and this node is your VB. What will be your VA? VA will be equals to 4 kilo ohm into minus I. Why minus I? Because this drop will be from up to down, right? So VA will be equals to minus 4 kilo ohm into minus I. 4 kilo ohm into minus I. And what will be VB? VB will be equals to 2 kilo ohm into I. So VA by VB equals to minus 2. This is your VA by VB. So that's the answer. Answer is minus 2. Very simple. Yes or no? This question is straight from Rajavi. Unsolved example of chapter 3 Rajavi. Last question you will see. This is straight from there. VA by VB equals to minus 2. And because of this concept only, now I have got this doubt. Which doubt? Where was our doubt? That gain thing. Here. This is the gain, but V naught by V in. Now what do I see? That it is equal to minus RD by RS as well. So what is the issue behind that? So I will post it on LinkedIn. We'll see what we can see. Okay. Now this circuitry you haven't seen. What is this circuit, sir? Again, find the gain, whatever they are asking. VD is the small signal input voltage. This time they did not show it by V in. They are showing by VD. So what you need to find? V naught by VD you need to find. Options are also given. You need to find V naught by VD. Sir, I can do this, but what this is, what this circuit is there. So this is your NMOS only. So I was going to tell you another thing, which is this thing. So how I represented NMOS? This is how I represented NMOS. This is how I represented PMOS. There is another way of showing it. What is the other way? Although here there will be dashed line. So the way would be, they will make a dashed line here. In that manner, they will make a dashed line like this. Yeah, just see here how they have made it. This is not actually usually famous. Dashed line there and then one there. Okay. So this is how they will make it. 3 dashed line are there. And this is full line. Okay. Same goes for this circuit as well. They will do the same thing. They will do the same thing here as well. So I am copying the same thing here as well. Okay. Then they will make one line here, one line here. Now they will connect this particular line to source. They will connect this particular line. Where is source in NMOS? Sorry, where is source in PMOS? Upper side. They will connect this particular line to source. They will connect this particular line to source. This is known as body actually. What this is known as body. All these things you know, drain, gate, source. This is known as body. This is body. Okay. This is body. They will connect that. Now the sign of arrow. So the sign of arrow, here it was outward, no. In this one it will be inward. Here this was inward, so here it will be outward. So this will be the sign of arrow. Are you getting this point? Are you getting this structure? Can you remember this thing? Very easy. Like a different kind of structure is there. That means inward arrow will be NMOS, otherwise it will be PMOS. So what is this? What is this? This is your NMOS only. This is your NMOS only, right? So can I make the circuit again? Yes. Let's start doing it. So this is my VD that they have given. This is your R naught. This is your V naught. Then there is a NMOS circuitry is there. This is connected to ground. This is your R naught. And here, this is R naught. R naught is, this is connected to ground. This is VD. This is VD here. This is your V naught. What do I need? I need the ratio of V naught by VD. This was asked in GATE 2022, which was my shift as well. Okay. And believe me, no one gave the answer of this question. When it came, no one gave the answer of this question. Later on, after some days, the answer was given. And I also posted the answer of this question. I don't know why. It is very simple. Just let me know one thing. Because they were solving it with models. And if you solve by models, it can take you some time. So if this is your V naught and this is your R naught, this is your R naught. How much current this will drive? 0 ampere current. Basically, this node is V naught. This node is V naught. Then there is R naught. Then there is R naught. And then there is a MOS, which is driving 0 ampere current. R naught, which is driving 0 ampere current. So what will be the voltage here? What will be the voltage here? V naught by 2. Because it is driving 0 ampere current, so you can divide the potential, no? I can do the potential division. If I have done the potential division, they have considered R naught to be infinity, right? Small R naught is infinity. A small signal low frequency VD voltage is supplied if channel length modulation of the MOSFET is ignored. So what line you can see? Channel length modulation of the MOSFET is ignored. What does that mean? R naught is equals to infinity. So R naught is not there. So basically what will be this potential? This will be V naught by 2. So this potential is V naught by 2. Can you write down the current in MOS? Yes. What will be the current in MOS? GM V naught by 2. We are only picking good question. Okay. Basic question you will be able to solve. At least if you are able to solve this one as well, then you don't need to worry about anything. You will be able to solve good problems in the examination. So what will be the current? GM V naught by 2. If this is V naught, this will be V naught by 2. So current will be GM V naught by 2. What will be the current in this R naught? The current in this R naught will be, this is your V naught, this is your V naught by 2. So the current in this R naught will be V naught by 2 R naught. This is your V naught, this is your V naught by 2. So the current in R naught will be V naught by 2 R naught. You know, will this VDD will be shorted? No. This VD is, now this VD is small signal bias. Again, I am saying the word bias. We cannot use the word bias for small signal. What they are saying, a small signal low frequency voltage VD is injected at the supply terminal. Here, a small signal VD is there. Okay, a small signal VD is present. So this is a small signal. You cannot short circuit it. So small signal VD will be there. The small signal VD will already be there. This is your V naught. This will be your V naught by 2. So current is GM V naught by 2. So at the V naught, can I apply the nodal? Yes. What will be the nodal? V naught by VD upon R naught plus in this direction V naught by 2 R naught plus GM V naught by 2 is equals to 0. Very easy it was. V naught by 2, GM V naught by 2. This is your V naught. Here in the R naught, how much current will be flowing? Basically from V naught, how much branch I can see? This R naught, MOSFET and this upper branch. In the upper branch, how much current is going? V naught by VD upon R naught. In downward, how much current is going? GM V naught by 2. Here, how much current is going? V naught by 2 upon R naught. V naught by 2 R naught. V naught by 2 R naught. That's it. What is V naught? 3 V naught by 2 R naught plus GM V naught is equals to VD by R naught. Right? So what we are getting? 3 V naught plus 2 GM R naught into V naught is equals to 2 VD. Okay, VD by R, V naught by R naught, 3 by 2 V naught R naught, VD by R naught plus GM. Yeah. So what we are getting? V naught by VD. V naught by Vd is 2 upon 3 plus 2 gm R naught. Whatever we are getting, okay, this is the answer. Well and good. Or what was given in the examination, as far as I remember, they took this 3 down. So what answer they gave? V naught by Vd they gave as 3 by 2 plus gm R naught inverse. This answer they gave actually. This 2 goes downward, so 3 by 2 plus gm R naught inverse. This was the answer given. As far as I remember, I hope there is no calculation mistake. V naught by 2, V naught by RD upon R naught, GM V naught. Okay. There is a calculation mistake. GM V naught by 2. Okay. GM V naught by 2. Actually, I am really tired. That's why this error are happening. So what will happen here? 2 R naught will be common. Then here this 2 will not come. Two upon 3 plus GM R naught. 2 upon 3 plus GM R naught will be the answer. Okay, so in that manner you can adjust it. Okay, let's remove it. Well, let me take a break, then I will come back and do the rest of the video. Yeah, okay, let's get started again. So this question was done. Let's go to the last question of our this particular video. After that, you will be much comfortable with MOSFET's amplifier. You will be able to solve a lot of questions, or at least 80% of the problems you will be able to solve from MOSFET amplifier. Okay. In this question, you need to find the voltage gain V naught by V in. V in is applied here. One thing I know, if I look at this circuit, then I know that if I know potential here, if I know the potential here, let's just say if this potential is Vx, then I can directly write down my V naught by Vx. What is my V naught by Vx? I told you one thing. You remember this expression. What is that? Minus GMRD. Right? Here, where I told you to remember. Here I told you to remember. Although this circuit I should have replaced like this. This is my R, and this is my V naught, and this is my VDD. So what will happen? VDD will be grounded. VDD will be connected to ground. So GMV in current will be flowing through R. So this will be the gain. So if I know this potential, Vx, then what is my V naught? My V naught is minus GMRD into Vx. When I draw the small signal model, now my target is to get this Vx in terms of V in. When I draw the small signal model, capacitor will be shorted, right? This current source, everything, this will be gone. This is my M1. So now the thing is, I know RB, everything is fine. But what about this particular circuit? How I can replace this circuit? So now I need to check from here how much resistance do I see. From this side, how much resistance do I see? My circuit has reduced to this part. From here, how much resistance do I see? Have we seen this part? Have we seen this kind of circuit anywhere? Yes. In the beginning only we have seen this circuit. What I will do? I will apply V in here. Why I am doing so? Because I need to connect, no, like this circuit I need to reduce. My final MOSFET that is useful is this one. So I need to reduce this one. And that I will reduce by its equivalent. What will be the equivalent resistance? So from here I need to check the equivalent resistance. And this is the circuitry I am having. Can I tell the equivalent resistance? What I will do? I will apply V in, get I in out of it. So what will be the equivalent? V in by I in. What will happen here? It will have two components. This I in current can go into this MOS as well, but in the MOS it cannot go. So where will the current flow? Here the current will go. Now this I in will have two paths. One is to flow through this MOSFET, another one is to flow through this R naught. But R naught is infinity. That means this I in will flow through this MOS only. This I in will be flowing through this MOS only. So this I in will be flowing through this MOS only. So what will be your I in? I in will simply be, if this node is V in, then what is the current in MOS? The current in MOS will be GMV in. If this node is V in, then the current in the MOS will be GMV in. So I in is equals to GMV in. So what is your R in? R in is equals to 1 by GM. R in is equals to 1 by GM. So this much portion can be replaced with 1 by GM. So what we are getting here? From Vs, what we are getting? From Vs, I can see Rs. or not Vs, this is your Vin. Now this node is connected to RB, and RB is in series with this resistance. RB is in series with this resistance. And what is that resistance? This particular resistance, that is your 1 by Gm. So from Vx2 you are having RB, and that is in series with 1 by Gm. And now this is your MOS. And here you are collecting your V node, which is connected to ground, and this resistance is your RD. This is your V node. This is your V node. Okay. So what will be the potential here? What will be your Vx now? Because this will drive 0 ampere current. So what will be your Vx? RB plus 1 by Gm upon RB plus RS plus 1 by Gm into Vs. So Vx you have find in terms of Vs. So what will be your now V node by Vs? That would be equals to minus Gm RD. What was your V node? V node was minus Gm RD into Vx. Minus Gm RD into Vx. Here you are having Vx. So V node was minus Gm RD into Vx. Now what is your Vx? Vx is equals to RD plus 1 by Gm divided by, sorry, not RD, it is RB. RB plus 1 by Gm divided by RB plus 1 by Gm plus RS. Okay, into Vin. Because I am replacing my Vx now. So Vs you can say, or it is Vin, whatever you can call it. So what will be your V node by Vin now? Vin can go here. So my V node by Vin is. So that's the answer. And this was considered as one of the finest problem in GATE 2024 examination. But that is very easy. Now it might happen that, sir, how it will click to me in the examination? Sir, it is very tough that all these things should click to me. Like it might happen that what if this is not clicking to me? But there will be options. What I am saying, there will be options. So if you have enough concept cleared and you have options as well, then believe me, you will be able to do, at least you will be able to attempt it in the examination. And if these 3 hours, if you have put your full concentration, then believe me, you will be able to solve as well. And 3 to 4 marks will give you much higher advantage than other students. Okay. If you are someone who is keeping MOS amplifier, that means like your preparation is decent enough. Your preparation is not that good. If your preparation was so much good, then you wouldn't be skipping MOS amplifier. But if you are someone who is keeping MOS amplifier, your preparation is decent enough. But what if in the examination you are able to solve these problems? Then your rank will be much higher than what you would be expecting. Are you getting this point? Okay. So yeah, I gave 3 hours for making this video, and I hope this was helpful. But now the discussion is, what's next? Because we are having 12 days, and in 12 days we can bring a lot of concept. So what's next? Okay, I am really tired, that's why I am not able to speak properly. So what next thing I should bring? I can bring more concept like that. So first you let me know in the comment section whether this was helpful or not. Like there is someone who did not even study it, or there is someone who was not even comfortable with MOSFET amplifier. Now what do you feel after watching this video? What do you feel about yourself? Are you comfortable with MOSFET amplifier? Do you feel like that you will be able to do the questions in the examination? Like these questions would have been much easier. This would have been much easier, and this would have been also much easier if I have given the option. In the examination you will get the option. So what do you think? Will you be able to do the problem in the examination? If yes, then comment down so that I will get to know if these videos are helpful or not. Because here I tried doing a different thing, at least 20 hours of content, 20 or 25 hours of content I tried to deliver within 3 hours. So just let me know in the comment section if it was helpful or not. If it is helpful, then I can bring more videos like that, because I know a lot of people will be facing problem in, let's just say, in op-amp only you will be facing problem in a Smith trigger, right? Or positive feedback application. All the positive feedback application I can bring. In digital electronics, I can bring the problems of a sequencer circuit. In EMFT, I can bring the problems on transmission line and oblique incidence, right? In control system, we can bring the video on Nyquist plot, polar plot, Bode plot, right? In network analysis, I guess you should be comfortable. Transient analysis is a bit typical topic, but I guess you are comfortable with that. So network analysis we can skip. Like in different subject, we can bring different topics, right? So certainly we can bring more and more content, but you need to let me know in the comment section, did you find it helpful? Was that helpful for you? If it is helpful, then only we will bring it, no? So let me know, let us know that what was the level, how you did you, like certainly it is a different approach that you might not have studied anywhere else. So this approach helped you or not, okay? Okay, then with that, I would like to end this video. Thank you very much.